Okay, for the record, it's Monday. The video number is 182. Let's make sure that number is correct. Yes, the last video is 181. We're still doing PAINT5D stuff. We're doing specifically the user interface rectangles. Our bitrate sucks, so no one's going to watch this. And we still want to do a good job recording this for our own self-documentation purposes. Also, we'll upload this to YouTube later in our archives. So let's kind of open up our code, right, and take a look at what needs to be done. So let's move this over here. Let's do Windows E. Let's go to the AAC 2020 folder. And we didn't actually write any extra code at the shop. Instead, we kind of researched how we were going to make a table and messed around on Facebook. Let's open up this build file so we know what kind of systems are going to be in what orders and all that good stuff, right? So we know that we want this UI frags and we want this Taudump thing, right? And we know the relative order, right? So basically we have the PAINT5D shader, and then we have we also have this like Gpuview shader, but we're just going to say, you know what? We're going to say, screw it. You know what? The Gpuview shader is kind of a very low-level shader. It's a low-level shader that is really for programmer debugging. It's not really for... It's really not meant as an end product kind of a thing. It's very low-level. So Gpuview, by nature of being declared up here, is not going to have access to any fancy UI. So any of the stuff that we want to do for Gpuview will be all kind of keyboard-based controls. That's fine. That's fine. That's the way we'll roll, right? So the first thing we want to do, which I keep on saying the first thing multiple times, but let's just open up another file so that we have something to put on the other side of the screen. And let's get to business, right? So I don't even know if we're streaming because the bitrate is this weird gray color. So who knows what's going on with that. So we want to say, okay, Taudump. Does Taudump need any special stuff in it, or is it well, first of all, do I already have code for Taudump? Did I already like make a Taudump? So let's go look for that for a second. So lib. And if we look for Jesus Christ, Taudump. It's like I changed one preview setting somewhere else, and then it persists everywhere else, and it's annoying as heck. View list, okay? And if we look for view details, there we go. Okay, there. Now we got a linear list. So yeah, Taudump. We already have kind of functions for this, and so we're going to Taudump into a subsection. And the idea is that if you want to understand how this kind of works, let's go open up Taudump for a second. Okay, so if we look at the data for Taudump, what we're going to do, right, in this tau thing, right, so this is diatau cell, right? So inside of diatau cell, let's just take this. Okay, and this one's 15. Okay. Do we just want to make these smaller? No, let's not make these smaller. So right here is this diagram is this diagram itself is what we're looking at, right? So this is a 512 by 512 section, right? And 15 equals tau, okay. And then 0 equals Uirects. Um, and so this is going to be editor memories, is this thing here. This is the first tau. And then the other ones are, so 1 to 14 equals unused as of date 2021 0315, right? So as of this time, these are unused as of this date. Okay, 2021 0315. So what the hell am I talking about here? What's going on? So within let's move this over for a second. Let's change how we denote this for a second. Let's make the diagram a little bit slightly different. Okay. And let's move this around. I don't know how we're going to write this. I don't know how we're going to denote this, but let's try to denote this in a way that looks kind of normalized. Okay, so yeah, we got these different subsections and what they mean. And basically we're going to take the Uirect one. So 0 is the Uirect section. So let's just 000 that for a second, just because I can. And we're going to say that this is diatausa, right? And this is dia subcell, right? And so what we want to do so this, can we just kind of like draw this in a way that'll help us here, help us kind of understand what's going on, or yes, no, maybe? So the cell right here, this cell right here, is going to end up, here, let's try to focus in on this. Can we just not worry about this right now? Can we just kind of like blank this out to focus on it? Right, so let's not even worry about what these other numbers are over here. But let's say we do, you know, 0 to, no, that's actually correct. And then, let's say over here, I know I'm not explaining this right now, but I will explain it after I'm done drawing it. I know I'm like all over the place here. So this one right here is dia subcell, right? So this right here is dia subcell, the diagram for the subcell. And they originally come from, the diagrams that we're looking at right now kind of originally come from a different thing here. But this subcell is 1/4 the size of the main thing, right? So this right here should be 128 by 128, right? Because it's a fourth. And so this is original diagram Tau depot diagram copies for Taudump, right? So we're basically just copying some diagrams. There we go. So we'll call them Tau depot diagrams for Taudump, right? So we know kind of like what the heck we're looking at. So let's kind of make this more symmetrical. 1, 2, 1, 2, minus 1, minus 1. Let's turn this even to an odd, because I'm OCD here. And then I don't even know if that's good. Okay, that looks like we're finally kind of... Okay, there we go. So Tau depot diagrams for Taudump. And we'll just hashtag it like that. That's how we'll label this diagram that we're looking at. And so when we're looking at this Taudex is saying which one of these cell indexes are we on, right? And then subdex 0 and subdex 1 are saying which one of these cells are we looking at. So say subdex 0 is this, and then subdex 1 is this. That means we're going to draw a selection rectangle that covers both of those cells, and we get this area here, right? And then that area in pixels needs to be the same size as pix width and pix height, right? So we can check to see if our math is correct. And so why the heck are we doing this? Well, we just need some facility to formalize where we're cutting and pasting texture subsections to a larger texture. Why do we need this formality? I can't... The simplest reason is the more rigid structure that you impose, the less error-prone your code, right? So the more structured and rigid we can be, the less problems we're going to have down in the future. Now, you can disagree with that. You'd be wrong, but you can disagree with that. But I understand if you would be skeptical, right? Because, you know, I've just given you something that's kind of like highly dogmatic. But that is my experience, right? More structure, better, right? It's the same reason why you turn on strict compiler warnings, right? The stricter your compiler is, the less problems you usually have from like weird bugs. So the stricter we can be, the more rigid we can be, the less problems we're going to have down the road. Okay, so we know that we're trying to like create a selection rectangle between here and here, but how do we denote this, right? So how do we denote this in a way where we can look at this diagram and be like, oh, know what we're looking at? So I think what we'll do is we'll say xy 0 here, and then we'll do like a xy 1 here, right? And the reason why we're going to write this here is so that we can mark it here at xy 0, right? We can make a little at symbol, or we can just say, do you want to say at? Yeah, at xy 0, right? So that does make it a little hard to read. Something like that, maybe. Except that's not quite right. Hold on. Okay, yeah, so something like that, right? So that we have a little tag in our code where we know, we just want to be able to see the connections between the diagrams and the code, right? So let's make this capitalized. So this is xy0, this is xy1. And this is just an example, right? So this is just an example of what it could be. So we could make a note that, you know, at, you know, xy0, example subdex 000, actual parameter, right? And then at xy1 is going to be example subdex001 actual parameter, right? So as we're drawing out the diagram, to kind of alleviate ourselves from the confusion that is abstraction, right? We're going to diagram this out with a very specific set of inputs in mind, right? So this is a 64 by 64 area, right? Example in diagram is a 64 by 64 pixel region anchored into the top left of dia subcell, right? And then we can make a note at vid IID. So the video is now 182 and the time is 16, and then let's just say 13, 16, 13, or actually 16, 16 amuses me, so we'll call it 16, 16. Okay, so right, we have the video number and then the timestamp at which we are in the video, so we can refer back to these recordings later, right? So yeah, we want to specify this cell index and this cell index, and then draw a selection rectangle in cells, and then we want to convert that selection in cells to actual pixels, and then we want to paste the pixels into the texture memory based on these cell coordinates. Okay, that looks good to me. So now the question is this math correct? So this tau dx, tau dy thing, we don't have such a thing, right? So we need to do like an index to xy formula to figure this out, right? So index to xy formula C99. Okay, so here's the index to xy formula. Is it the one we want to use? Well, it says index to xy formula C99, so I'm going to say that's correct. So the first thing we might want to do is fill this out, right? So here's our x's, right? So take our x's and just cut paste. And you'll be like, why are you cutting and pasting code? Doesn't that make you a hack? Well, it's not like I'm cutting and pasting from Stack Overflow. I'm cutting and pasting from my own code, right? These are formulas I already wrote. And the idea is that if I use these common snippets like all the time, then it's less likely that I made some type of logic error. And as long as I'm very careful about how I change and refactor it, I'm going to avoid a lot of mistakes from just doing the math wrong, right? So then this is pixel index, right? So the pixel index for this is going to be derived from whatever this tau index is, right? So the tau index is this. So wherever we see pi for pixel index, it becomes this. Now this width here, the width in the formula, if we look at this, well, it's 4, right? There's 4 by 4 cells in both of these diagrams here. Now, I thought that something else used a different number of cells, so I'm kind of scared here. Oh yeah, this thing right here uses 16 by 16 cells. We're fine. So this width, we might want to say something like, something that kind of tells us what the heck, tau width, right? Call it tau width or something. And then over here, we're also going to need another formula for this right here. But let's do one thing at a time. So we got this tau dx, we got tau dy. We also need the type, right? So we'll just call it int32. That should be fine. And then what else do we have to do? Let's just take this and do we really want to keep notes of what formula we're using? I mean, I guess it kind of is self-documenting, right? If we have the shortcut, we know that it tells us what the code does and also tells us how to find this snippet again. So I think I should keep it. I think I'm going to keep it. I do want to underscore it like this just to make it easier, because then when I double-click this, I can see both of these pop up. So this formula here, I see we have sub x0, sub y0, sub x1, sub y1, and those are the same kind of formula, except we're using subdex 00 and subdex 01. And the thing is that that this is kind of like annoying in the sense that the code is going to be slightly differently aligned. So I'm going to take this and I'm going to put this in the comments over here. And then instead of calling this subdex whatever the heck, right? Instead of calling this subdex this, subdex that, note, subdex right? And then over here, we're just going to make these shorter, right? So note that subdex001 is equal to sub001, right? So we're just going to make this a little bit more terse. And the reason we're going to make it terse is because we're basically going to execute the same kind of indexed xy formula on this variable, and this variable, and this variable. And it would be nice if everything was just the same width in terms of the number of characters within the tokens, because it's just going to make things easier in terms of cutting and pasting the code, and I'm a hack. So if we have it like that, we can just easily say, oh, this is right here, this dex right here is sub 000, right? And so wherever we see that index, we can call it sub whatever the heck, right? And then for the other parameters, for these other variables, we see the sub x0. Well, that's going to be wherever we have these x's, right? So just paste these x's, right? We have a sub y0. Well, we're just going to paste these y's, right? So tau width, we're not going to use tau width, though, right? Because this is not the width of the tau. It's now the width of the sub, right? The subcell width. It's the same value. It's still 4 by 4. But let's just call this sub width, and we'll call this sub width as well. And those are going to be macros that are defined locally. Okay, so now we're just going to cut and paste this formula one more time. And then everything is pretty much the same, except instead of zeros, we have ones, right, for the upper bound. So sub 1, x1, y1, and this is an x1 here, right? So the next thing, before we go any further, is just a sanity check. So we want to go highlight the x's and then the y's and make sure that the pattern seems consistent. So we're going to highlight the x's, we're going to highlight the y's, and then we're going to highlight the indexes, and we're going to make sure that each one of these, and we can also highlight these widths, right? And we can see that we have the same exact color pattern in all three of these chunks. So this chunk here, and this chunk here has the exact same color pattern, so that's good. So the next thing I want to look at is, okay, so we know that the x and y components and the indexes seem to be in the correct locations. What about, what's the other thing we could possibly get wrong? Upper and lower bounds could be a thing. We also want to make sure that if we highlight all of these, right, and we highlight all of these, that there's no color interlacing between the different blocks, right? So if we look at that, no color interlacing. This, and this, there's no color interlacing between those blocks. So we're using token highlighting to just do a sanity check and make sure we haven't done any stupid transposition mistakes. So the other thing I'm worried about is the zeros. So I see we have the ones, and then we have the zeros. So if I do like, let's highlight this and this. So here's the ones, and here are the zeros, right? And that's a little bit more hackish, but we can see roughly that that's correct. Okay, so now the next question is, are the x's and y's in the correct place? So if we look at this, we have the index location, the 1D index location, modulus the width. So the width is the stride. So the number of full filled rows is... Oh, okay, no, never mind, that's not correct. It's the remainder, right? So we take the number of rows we can fill up, and then whatever is left over is the remainder, and the remainder is your x value. And then we're going to take that remainder and subtract it from the one-dimensional index to get a number that is, it goes in evenly with the stride, right? The row stride. So we take this, we chop off the remainder so that when we divide it by the width, it goes in evenly, and that's the y, right? The y is the number of filled rows, right? So it's the same formula for each one of these, right? So we're going to take the index, get the remainder, that's the x. Take the index, chop off the remainder, divide evenly, get the y. Take the index, get the remainder, that's the x. Chop the remainder off of the index. Now when you divide, it goes in evenly, and we get the number of rows that are filled, and that would be the y value, right? So if you do traditional scanline order, this is the correct formula. So that all looks good. That all looks good. We just want to make absolutely sure that that looks correct. The next thing is, are we using these everywhere we should be? So here's the x, here's the y. That's good. So we're multiplying that by 128 because each one of these cells right here, each one of these cells here is 128, right? So if we look at this, each one of the cells are 128 by 128 cells, right? And then over here on this side, what we're looking at is not the same thing. We're looking at cells that instead of being 128, we have 32, 32, 32, and 32, right? 32 and 32 is 64, 64 and 64 is 128. So these are 32 by 32 pixels in cell size, these things here, right? Okay, so now that we know that, this multiplication by 128, that's correct. Then over here, we have a multiplication by 32 because this is 32 by 32. I'll just put a 0 in front of that to make it even. I don't mean octal when I do that. It's just my hack. I mean, we could just call it underscore 32 if we really want to balance that out without confusing it for octal. So times 32 here. This is the top, right? The x0, y0, right? We take the index and get the x0, y0 in terms of the pixel location, right? And this is the y1, the x1, y1 location in terms of the pixel index. Okay, excellent. We're not out of the woods yet because actually what we've done is we've created a set. If we have a upper left corner here and an upper left corner here, then our selection rectangle is going here to here, right? But we want to go from here to here, right? So that means that we have to add that this right here is not quite correct, right? So x1 equals x1 plus 32 minus 1, right? Because we're already on the current pixel, right? So we don't want to jump more. We don't want to jump 32. We just want to jump 31, right? So if you had a thing that was 2 by 2 pixels, then you have pixel indexes 0 and 1. And so to get to the next pixel, you wouldn't jump the full width. You would jump the width minus 1, right? 0 plus the width minus 1, which is 2 minus 1 is 1. Yeah, I don't know. Trust me, we need the minus 1 to make sure we're not off by 1. So the y1 equals, y1 plus 32 minus 1. Okay, so we're going to do the correction here because you need this correction because we want the bottom right pixel, not the top left pixel, to get a selection rectangle covering all of the dia subcell right? So we can make a note of this, so we can say, that is, at vid IID 0182, right? And since we're already here, right, and we want to know that this commentary goes to, what this commentary goes to, we can just put it over here as well, right? We can do this one more time and say, oh, at vid 182, and the time is 30, and then 3010 maybe. We could say 3010. And we're a little bit out of room, so I don't know how we're gonna do this. I guess if we kind of bring this in a little bit, maybe we can. If we just bring it in a little bit here, maybe we can get this working. Yeah, if we make this a little bit more compact, we can just squeeze that in. Let's just change the time to 42, because we want to be cool. So let's just change that time to 42, right? So now when we're looking at this commentary, we know 182 applies to this formula here, and this formula for here. So here's the x1. We're going to offset it to get the lower right corner, and then over here we're going to also offset this to get the lower right corner. So we do this formula first, and then we do some corrections to it. Okay, so now that we have these corrections, we want to do the width check and the height check, right, of the bounds of the selection area in pixels. And if that selection area in pixels is not exactly equal to the pixel width or the pixel height, then we have a problem. So if we look at pixel width and pixel height, it's this thing here, right? So this is the size in pixels of the data, right? And this is basically where we want to paste the data, right? So dimensions of bitmap to paste into texture memory, right? So that's what this is. And then over here is the location in texture memory to paste to in, right? So specified using cells. And then this thing here is the bitmap data to paste into texture memory, right? So that is what all these parameters mean. So I don't know if we need to label it like that, but I think it could be helpful to kind of give an explanation of what these clusters of parameters are. It is a little bit busy like that, but oh well. Okay, so now that we have that, we have the CPU picks. Is just going to always be Taudump CPU picks. So this is called Taudump. So always Taudump memory because memory we don't have any use for a generic helper function that dumps anywhere else, right? So we're not gonna never make your code more generic than it needs to be, right? Trying to make your code more generic than it needs to be, you end up writing more code. You end up writing more code, and the code ends up being more abstract. So it's like a double whammy of badness. So so we're not going to make a generic helper that lets us swap out these different memory regions. It's always going to be this. And, you know, if in the future we need some type of generic function that does this kind of functionality, then we can refactor it, but never make it more generic than it needs to be. I can't stress that enough. Okay, so now that we have this, don't we have some type of GL subtexture push kind of deal somewhere in here? And I know we do somewhere, and I believe it's in Tausync actually. So Tausync has kind of like the correct implementation of subtexture push. So subtext something or other in here, and actual subtext push right here. So right here we can see Tausync GL text sub image 2D pixel bounding rect. Okay, so it takes a pixel bounding rect. Cool. Now, does it do anything else? Nice. So what I'm thinking is we just copy this, paste it, and just get rid of all the commentary. That's what I'm thinking we do. So let's do that. Let's create a helper function. It'll be void AAC 2020 Taudump GL text subimage 2D. So GL text subimage 2D, and let's just do a rec pointer, right? Let's do a rec pointer. Do we want to do a rec pointer, or do we want to write it a little bit differently? I'm thinking int32 x0, int32 x1, x's then y's, right? General to specific. int32 y1, and then a U08 array pointer CPU pixels, and then we could also say right, we could call it this. Now, have I done something like this? I feel like I have before, but let's go find in files and make sure that this is something that already exists, so we know. Rec x0. Okay. And what is that called? Like implied object code smell? I think that's what it's called. Let's go try to find that for a second. So I know what I'm talking about, but implied object, implied obj, implied object code smell, code smell implied object. Let's go look for implied object, because I know that's what it's called. Let's go look that up, see if we can find it on the internet really quick. Oh, we already got all our push-ups done and whatnot. Bloaters are, long parameter list. More than 3 or 4 parameters for a method. So, first of all, okay, I'm going to say, like, so code smells are not necessarily a bad thing. Let's read this. It's hard to understand such lists, which become contradictory and hard to use as they grow longer. Well, guess what? This isn't growing longer, right? We know exactly what we want to do, and we're not growing it longer, right? It's exactly as long as it needs to be. And it's not changing, right? We're not writing flexible code. We're writing very rigid code. Instead of long parameter lists, a method can use data of its own object, right? So pass it to object, right? But you've just once removed the you haven't gotten rid of work. You've just increased the surface area, right? Now you got a struct that you have to fill out, right? I get that it can be more flexible, but we're not trying to make things more flexible. Instead of a long list of parameters, a method can use data of its own object, and the current object doesn't contain all necessary data. Another object which will get the necessary data can be passed, yeah, as a method parameter, yeah. Treatment. Payoff, more readable, shorter code. I disagree, right? Because this doesn't make the code more readable. Because we actually want to, maybe if you're using IntelliSense, that actually makes sense. But we're not. We actually want to, when the function's called, we want to see exactly what's going into that function. If we're wrapping things in a whole bunch of different kinds of objects, we're not going to be able to see that. And we want the kind of guts exposed. When to ignore. Unwanted dependency between classes. Okay, I totally agree with that. But that's not what I wanted. So I'm just going to say, you know what? Can't find this. Go watch talk. Code smells. Close match, but not long param list. Okay, so long param list smell, right? So we're going to paste that in there. And I don't know, we'll maybe watch this talk some other time. I know the answer is in this talk for the code smell for this, so maybe we can find that really quick. So maybe if we go look this up, right?
And if you add generality, you increase the level of abstraction of code. Very often that means adding levels of indirection, which humans are terrible at, and it means that every time someone looks at that code, it's harder to understand. So we should really...
BAM! I don't know why I saved it at that point, right? So be careful about that, right? You want to say, oh my god, my parameter list is too long, let's go send it an object instead. Well, guess what? Now you have increased the indirection and made things more complicated.
Really try to restrain ourselves and not speculate about the future. When the new requirements come in, they'll tell us how we wish we'd written the code, and we can do it then. Dispensables, sorry, here. See, I did that thing with a clicker. Dispensables, you've all seen it. Okay, so we'll move on. So the last category here is this group. Feature envy, inappropriate intimacy, message change of middleman. Feature envy is when I have an object, Joe's down here, Joe's an object that I know about, and I send him way more messages than I send myself. Could be that I'm more tightly coupled to Joe than I know, right? Inappropriate intimacy would be if Joe had a bunch of private methods and I reached in and got them. Okay, that would be bad. I really am sort of pushing the code of conduct, aren't I? Sorry. I hope no one is made uncomfortable by that. Message change, there's a...
Okay, I find that funny. I'm going to bookmark that. So that was what, probably at a time, and I hate how YouTube is now changing the URLs. At time equals probably 9 minutes and 20 seconds, probably. Copy it, try to go in there.
I had a bunch of private methods and I reached in and got them. Okay, that would be bad. I really am sort of pushing the code of conduct, aren't I? Sorry. I hope no one is made uncomfortable.
But yes, I find that hilarious.
Than I send myself. Could be that I'm more tightly coupled to Joe than I know, right? Inappropriate intimacy would be if Joe had a bunch of private methods and I reached in and got them. Okay, that would be bad. I really am sort of pushing the code of conduct, aren't I? Sorry. I hope no one is made uncomfortable by that. Message change, there's a law examiner. Those violations, right? You got dots. You have you send a message to something you know about, and you get a response back, and you send another message. If the types change across those dot change, that's a message chain. Middleman is if you have an object that you send messages, and its sole purpose in life is to forward those messages to somebody else. Maybe you don't need that object. These things are called, they're grouped together in a group called couplers, because the effect of this is that it binds the objects together such that even if they're beautiful, even if you've tested them, even if they're little works of art, you can't ever reach in and get one out and use it in another context. They come as a bundle, all or nothing. And so there you go.
Okay, let's see what we got. Long method. So long method is actually the thing. Yeah, it's probably at the very beginning.
It's like naming things wins. I suspect all of you, every one of my classes. And so we all. And so one of the things they talk about very often, it's like a recipe book. Okay, this is a list of things that just do not need to be that big. Long method and large class are probably self-explanatory. Data clump is when you have two or more pieces of data that always appear together.
Ah, data clump, that's what I mean. So time equals 3 minutes and let's say 42 seconds because we want to be cool. Copy that. Let's go make sure that that looks good in terms of the timestamp.
Let's just talk about this set. Okay, this is a list of things that just do not need to be that big. Long method and large class are probably self-explanatory. Data clump is when you have two or more pieces of data that always appear together. Pass them around.
Yep, data clump. It's data clump. So in our notes, right, we can change this, right? You mean data clump code smell. So what I actually want was data clump code smell. So we're going to go in here and just say data clump code smell. Okay. DC smell for data clump smell. Right, and then we'll put that in there, right? So now we have that for reference. The other thing I'm worried about is this is a talk that I have referenced more than once. And so, okay, we already have it saved. Okay, good. So I just want to make sure we have that saved in our reference before we kind of like forget that it's there. Okay, cool. So I'm gonna put that on the other screen. I just wanted to document that. So so at this, right? This is yeah. Okay. So right here, this is an intentional data clump, right? I do not. This is a. I know what the rules are, or I know why people say to do it one way or the other way. But I'm explicitly in the documentation. We're just gonna put this. We're gonna put this in the. And it's going to be at, so an at means it's a more generic comment that could apply in more than one spot, where a hashtag comment is something that is supposed to apply in a very specific, a hashtag is an extracted comment that has been offboarded into this file, whereas an at is a generic circumstance, if that makes sense, right? So these little ats could apply to multiple blocks of code that are different, whereas the hashtag applies to a very specific block of code. Means the parameter list is intentionally using a large number of parameters that are always passed together in exactly that order. Yeah, don't refactor it. The idea. 1. Reduce abstraction. 2. Make the code more readable. Using IntelliSense to have to peek into an object passed to a function is not readable code. Readable means I can print it out on paper and literally read it. So hold on. Okay, anyways. Gonna rant to somebody. Okay, so yeah, so we got this kind of intentional data clump. And also, you know, don't can use some slang. Right? It's our code. We can say whatever we want to say, right? So this thing here, I want to know, well, what does this section mean, right? So app Okay. So yeah, we just want an explanation of what we're talking about. And we have some very strong, batshit crazy opinions. So we might want to make a note of when this was, so, you know. When do we make this note? So at 182, and the time is 0055. 5532, or do we just want to wait for 42 so we can be cool? I think we're just going to wait till 42. Yeah, if I say don't refactor it, don't refactor it unless you absolutely know what you're doing. And so do not refactor this. It's an intentional data clump, right? So CPU pixels, likely a 512 by 512 bitmap representing texture memory. Okay, right now it is, so let's just say okay, so I'll also this selection rectangle, right, is going to have to go over another rectangle, isn't it? Oh, okay, so we're going to cut and paste into CPU pixel, and then we're going to upload. Okay, got it. So that means that this GL subtext image 2D, we're going to take this rectangle, but we also want to but we also need to take this thing here, don't we? So this array of data, okay, so we have to actually extract this. Okay, that's fine. So we need a... Ooh, that might actually change how things are done. So rather than CPU pixels, we're going to say, we're not going to say this. We're going to identify it by, I don't know what this needs to be yet. Okay, so we need like a UO8 array, right? And PNG pixels. Right? Something like this, right? Okay. So something like this is what we need. So it's effectively a GL subtext image 2D push, but it's just slightly, it's written slightly different because of its use case, right? So we can give it the exact same name as over here, right? But the signature can be wildly different because it's for a different system, and it has a different use case. So I gotta take a break. We'll try a 20 minutes. I'll be back. Ouch. How much time I got? That's what I thought. Okay. Get our sweater on here. Okay. Let's get back to figuring this stuff out. Okay. So we got this kind of texture, whatever the heck thing, and we're going to write some stuff in here. And then the question is, well, what goes in here, right? And actually the editor index is going to be used to identify the CPU side bitmap for now, right? So if we want to know what we're doing, we can go into open up and we can go cur editor, right? And in cur editor data, we have these different editor indexes, right? Gpuview, etc., right? So dex eddy, I guess is what it's called. Yeah, dex eddy. So eddy dex is not correct. Yeah, we want to do dex eddy. Right. So this is dex eddy 0, right? This is, you know, dex eddy 1, right? Etc., etc. Like all these things over here are dex eddies. Right, if we want to connect those dots, now we're connecting those dots, right? So C, right? So if we want to know what that is, example, oh, I see. Okay. So if right. If a dex eddy equals PAINT5D, okay, do something here. Else, you know, right, to do whatever the heck. Right, else, and it's not 2020 anymore, so that error message is actually incorrect. It's 2021. Okay, so here we're going to say, you know, what do we want? So we're just going to say, you know, U08 pointer, right? And it's going to be called CPU pixels, right? And that's going to be initially set to a null value. So it's going to be a U8 pointer cast of 0 initially. And then over here, we're going to say that CPU pix equals AAC 2020, pix name, and Taudump, right? Because that is the memory associated with the Gpuview. So we got a little bit of non-normalized code, which kind of sucks. So we might want to make a note of that, right? If we're looking at this and we're trying to find this, right, well, what does that mean, right? We don't have that, so let's just say at pat brk, right? At pat brk. Shorthand for... Alright, shorthand for at pattern breaker, right? And at pattern breaker we should already have in the code somewhere, so if we look for that, we can see, oh, hey, there's at pix name pattern breaker. Do we have anything that's just pattern breaker? Oh, we don't. I thought we would have. At pattern breaker. Okay, so for this, right, we want to know what that is, and I thought we had already documented this, but I guess not. So let's just take this, let's paste this over here, and let's chop this over here, put this here, put that there, and... Oh, okay, we're done. Okay, cool. So this is... code that breaks the regularity of the structure, and it sucks, but the real world is messy. Yeah, so it sucks, but right, so at vid 182, at the time of 125, let's say, right? So we made this note at this time, right? Pattern breaker. So this stuff here, right, we're going to use these editor indexes to kind of formalize what's going on. And if we're in here, CPU pix is going to be set to AAC 2020 pix name PAINT5D. Right, so that kind of, see how the names are one for one here, right? PAINT5D and PAINT5D. Whereas here we have Gpuview, and then we have Taudump, right? Taudump and Taudump. So that also means that AAC 2020 pix name Gpuview, close but wrong. This is also wrong, close but wrong. Okay, so that sucks that that's kind of a pattern breaker. Oh well, that's the reality. Not implemented. Okay, so right here, what are we doing here, right? So right here is pick correct CPU side bitmap, right? So all we're doing is we're trying to pick the correct CPU side bitmap. Okay. And then to make sure we're not in any trouble, assert that 0 is not equal to CPU pix, right? Make sure that that's, or assert, right, assert that it's not non-null when we get outside of it, just to make sure that all these else's kind of worked properly, right? Okay, so we got this, we got the dex of the editor and all that stuff. So after we've kind of like picked the correct memory, so else, this should be else like that, right? Okay, so we have these else's, the dex of the editor, right? is going to line up with a different CPU pixel allocation. As a CPU side, bitmap representing a texture. So after we do that, we want to error check inputs. So we should probably error check some of the inputs. And in these inputs, we want to just say, you know, if PNG width not equal to rec x 1 minus rec x 0 plus 1, right? If 0, or this case, or the case for the y, right? So the y case would be this. Or what else could go wrong? This PNG pixel could be null, right? So we got PNG, oh, that needs to be PNG height. Or U08 pointer 0 is equal to, and that would be PNG pix, right? The PNG pixels. What else? Or dex eddy less than 0, right? Okay, any of those cases, we got trouble. So we'll just say, you know, error input checks failed 2021 0315. Okay. So now that we have kind of this stuff here, we got our input checks. We have the CPU pixel allocation, and now we want to figure out how to do the texture push, right? So we've already kind of figured it out once, right? So we can kind of start stealing this code, right? So the first thing we want to do is we just want to do a copy. Texture pushing steps. Okay. So in here, we're going to do the texture pushing steps. Okay. Step 1. Copy to CPU pix. And I don't know if we want to make this kind of lowercase, maybe. All right, so step 1. Okay. So this is the first step. And the second step, step 2, is push to GPU texture, right? So after we have copied to the CPU pixels, we want to push to the GPU texture, right? So push to GPU texture. Okay, so we can make a little note of what the steps are and the little header of this. We can also make a note of at what time we did this. So in video 182, with a time of 1 hour, 32 minutes, and how about 32 seconds, just because that amuses me, right? So the steps are copy to CPU pixels, and then we're going to push to texture, right? Those should be the only steps we need. So when we're looking at this, we got step 1, we got step 2, right? And they're all highlighted nicely, so we can click these and actually see where that code is, right? Because these sections might get a little bit big. So the first thing we want to do is, with this PNG pixels, right? We want to go like for you know, int32 px equals, or py first, equals equals rec x0, right? Rec x0. Py is less than or equal to rec x1 and py plus plus. Fortunately, that's a little bit condensed here, so unfortunately what we can do is we can just try to put a little scope on that, right? And then we could say, you know, I32py, we could put the declaration there, and then we can shorten this just enough to where we have room for everything, right? Where everything's kind of nicely laid out, right? And then we can put this here, okay? And we're doing py first, okay? And this is px. Okay, so scan line loop through graphic, right? So we're going to scan line loop through the graphic, and then what we're going to do is we need to figure out the source bytes, and we need to find the rec index, and then we need to find the CPU dex. So CPU pix. Okay. So rec dex equals some type of formula, and then CPU dex or we could say this, right? Source. I don't know. Well, let's try to be less abstract, not more abstract. So PNG dex. So this would be PNG and this would be okay. So pxpy pixel x of PNG pix. Okay, this is pixel y of PNG pix, right? So we're going to loop through PNG pixel and copy to CPU pix, right? So px and py. This is going through the PNG pix, right? And so then we're going to do index to xy c99, right? So index to xy c99. Oh god, that's a lot of code. Let's take one of these, right? And make sure that that's correct, right? So actually that's not correct. We want xy to index c99, my bad. And this kind of index formula needs some changing here. So we can say that, let's take this index. So this is the index we're trying to calculate. And then we have the x location, right? So this is the px location. Here's the y location. So here's the py. And then we're going to multiply it by the width of the image, right? So if we look at this right here, it's the PNG width is what we want to use. So in the formula, times PNG width. Okay. So that's the index of that. And then the CPU pix dex, we need a pixel x of PNG. So we also need a okay, so CPU width, that is going to be, let's not worry about making a macro, let's just call it, maybe we do want to define CPU width 512. We're not going to use CPU height, but let's just hard code that as well, right? CPU width and height. It's kind of ugly, but let's do it like that. So, undef CPU width, undef CPU height. Okay, so the width and the height we have right over here, right, because of the image size. For all our memory, we're using 512 by 512 on the CPU side bitmaps. And then over here we can say CPU width, right? So this is a constant, whereas this thing depends on the input parameter. And then, so int32 cx is the pixel x of CPU pix, right? And then int32 cy, oops, I forgot the colon there, pixel y of CPU pix, right? So we just want to make everything kind of very regular, very normalized. CX and CY can sometimes stand for cell X, cell Y, but not in this case. PX, PY, pixel X, pixel Y, right? So we got the pixel index, but there's still a problem here, and it's because this CX, CY was never calculated, right? So how do we get that CX, CY? Well, it's going to be that should be based on the origin of this, right? Because we're going to paste it, right? Yeah. So CX equals rec x0 plus px, right? CY equals the rec y0 plus py, right? So here's CX, here's CY, right? So we're taking the origin, the top left corner, and we're offsetting with the X and the Y. So we're gonna, right, because that should never, now we want to make sure that this CX, CY, let's assert that CX is greater than or equal to 0, and CX is less than or equal to 512 minus 1, right? Like that it should be within the bounds, right? Because this is the CPU location, right? So if that's out of bounds, then we have a problem. So CY is greater than or equal to 0, and CY is less than or equal to 512 minus 1. Okay. So we calculate this, we calculate the XY of the destination, Okay. So source XY, and this is dest XY, right? So we have the source XY and the destination XY. So PX, PY, all calculated correctly. Index XY to index formulas, right? So we're going to use the index XY formulas here. And then the other thing is we're doing this in more steps that need to be done, but PNG pixdex. Okay, and then we can set these to trap values, right? 0 minus, right? Why not set these to trap values? So right. So we could say equals 0 minus 1, and we'll fix this up a little bit better. Oh, I see. We don't have much room to do that. Let's remove some of these spaces and make these trap values a little bit more terse. That almost saves us. Equals 0 minus 2. And then equals 0 minus 3. Need our semicolons. And if we do that, we're in a little bit better standing here. 1, 2, 3, 4. So we're just adding some trap values, right? So the other thing we need is the component index, right? So we have this thing, but then we want a thing called, instead of pixdex, we want comdex, right? So right, and this is pixdex CPU, right? Over here is pixdex, or wait, comdex. Comdex of the PNG array. Now, what's it called? PNG pix, right? So PNG pix versus CPU pix, right? So PNG pix versus CPU pix. So this is comdex of CPU pix. Right, so we can see the connections between the different chunks of data, right? We just want to be able to know what the hell we're looking at. So we have that there. Oh, and this is all kind of defined within this local scope. Geez, okay. So then over here, all we got to do is multiply by 4. Right, that's all we do. So CPU pixdex times 4, right? So, and this is comdex. So the component index is just the pixel index, right? So if we do PNG pix, we can see, oh, I guess we can't really do that. But PNG and CPU, see the PNG line and the CPU line, right? So pixel indexes to component indexes, right? Right, so we're taking the pixel indexes and we're converting them into component indexes. And then once we've done that, we can just copy, right? We can just go, hey, CPU pixels, where the heck you are. We're going to do the CPU comdex plus 0. And that is going to be equal to, and we'll set it equal to PNG comdex oops, sorry, PNG pics, right? And then PNG comdex plus 0, right? So it's a direct copy of the individual channels, right? So R, G, B, and A, right? So that's all we have to do. Now I can kind of see why OpenGL kind of uses byte arrays, because we have a natural loop unrolling when we do this. But at the same time, if we just use everything as uint32s, then that would technically be loop unrolling as well, because we wouldn't need to do this component index stuff. So CPU pixels, right? We're going to take the component index of the CPU stuff, plus 0 offset for the red channel, and we're going to access the PNG pixels, which is what we're going to copy over, right? So this is the source. The PNG pixels is the source. And plus 0, so red, green, blue, and alpha, right? Right? So that all looks kind of correct. Nothing looks accidentally interlaced here. Okay, so we can also say, you know, that's red. Okay. This over here is green. This over here is blue. And then this over here is alpha, right? Red, green, blue, alpha. So copy RGBA components. Alright, so that is what's going on over here. Okay. And we might want to say that is a mouthful. So we're going to use a macro for this. So CPU component index plus 4, actually plus 3, my bad, plus 3, is less than or equal to 512 times 512 times 4 minus 1, right? Because if it's over that, then we're out of bounds, right? So the PNG component index plus 3 needs to be less than PNG width times PNG height, right? PNG width times PNG height times 4 minus 1, and that is kind of doesn't quite fit, does it? We could just put these asserts like right here, maybe. Ooh, not quite. Let's just we're going to add a little bit of indirection. We're going to add just a little bit of indirection so that we can get this kind of fitting here, right? So if we do that, then we can just say, hey, assert that the CPU component index plus 3 is less than 512 times 512 times 4. And then we can also do the same assert for this PNG component index. And then we can just undef this, right? So we can just make these local defines, and then they kind of like help reinforce the section, the step section that we're in, right? Okay. And then that also means that our macro section over here can't collide, so none of these values should be here. So I know we've done a define for assert, so let's just say ASS is just an assert, and that will be kind of our 6th macro that's kind of encapsulating this dump asset, blah, 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 kind of section of code. So then undef, we're going to undef, what the heck was that? It was assert. And the other thing is that we cut and pasted this, and this is a disaster. Okay. So let's fix that up. And then over here, we have 06, right? Okay, so now that looks a little bit better. That would have never compiled. Okay, so we have this Taudump. Also, let's just make a note here. 1, 2, 3, 4, 5, 6, 7, right? 7 letters, right? Also, right, 7 letters because we can divide it up like that if we want. So this Taudump token, I just want to make sure that that is the correct amount of letters. So we'll just do a spot check right there. Okay, so this is a GL text subimage 2D call. Basically, it's a wrapper for that, but it has a very specific format. Here is the rectangle specifying the selection rectangle of PNG pixels. Ooh, hold on here. This rectangle is a destination rectangle, actually, right? Yes. So when we're sampling from PNG pixel, that value needs to be zeroed out. So are we doing that correctly? So let's go look at PX, whatever the heck. No, we're not doing that correctly. We got this all wrong. This rectangle is where we're pasting to. Oh, god damn it. So PX is the source location, and the source is always at 0, 0. Source is always origin at 0, 0, right? So the source is always origined at 0, 0, because it's just the entire bitmap. It's the entire bitmap that we're going to paste into a larger bitmap. This is the larger bitmap. Okay, this is the larger bitmap. So if we want to look at this again, let's make another air check, right? So if PNG width is greater than 512, or PNG height is greater than 512. So if 0, or this case, so let's codify what we've kind of figured out here. Okay, so in this case, air subimage to copy is larger than target. Right, so we are always pasting the entire PNG pix to a location within a given 512 by 512 CPU pix. Right, at vid IID 0182, with the time being 1 hour, 56 minutes, and let's just do 42 seconds to be cool people. All right, so we're just codifying what I just realized, and then we're gonna go fix our code. And I can't believe I made that mistake, but a problem well stated is a problem half solved, right? So that is kind of what we ran into. So greater than 512, yeah, so greater than 512, we have a problem, right? So if we look at this, this is wrong, so let's just change this, right? So this needs to be, this starts at 0, right? And then less than or equal to PNG width minus, PNG height minus 1. right? Because it's inclusive. And PNG width -1, right? And then, right? And then we still have this offset here, so this is good now. And then the location we're pasting into the destination image, that needs to be offset by that origin, right? We want to assert that CX is kind of less than or equal to is in this thing, but there's another assertion we need to make. We need to assert that CX is greater than or equal to rec x0, right? We need to assert that CY greater than or equal to rec x y0, sorry, y0. Can we fit all that? Oh, I guess we can. X's, and we almost made a mistake here. So X's and Y's, right? So the general bounds and then the specific bounds, right? So these are the specific bounds that we're working with. And so this XY should be within these bounds, right? So if this math doesn't work out, we have a problem, right? Okay, so we got some more bounds checking, so that's good. We got the minimum bound, the maximum bound, maximum bound of the destination location. So this is the destination X and Y. All right, calc dest X. Right here, we're calculating dest Y, right? Okay, so CX and CY are the destination locations. Okay, does that look good? Is there any sign of transpositions here? And it doesn't look like it, right? So this is the min-max over here. But we just add the min here, right? Because we just want to offset to the origin. A local to global kind of conversion there. And then right here, we can denote this. We can make a note of what this is right here. So we could say, do a Visual Basic style here and just say PY, PX, scanline order. Scanline order, that's why it's PX, PY, and PX. So if we see that, right, so if we see some code that says at scanline order, what do we mean by that, right? Probably it means a doubly nested loop where y axis is the outermost loop and x axis is the inner. Outermost and innermost, there's only two loops here. So outer loop and inner loop. This might seem like a pattern breaker because we usually want to write x then y for consistency. But in this case, we want the result of the innermost scope to traverse the pixels in scanline order. Okay, left to right, then top to bottom. make a note of when we wrote this. So 182, and the time is 2:02, and we missed 23, so 2:02:30. Sure, why not? Okay, so scan line order. That's kind of what I mean. Okay, so going back in here, does everything look good now? Right. So we got the PNG pixel index, right, which is oh. Okay, no, yeah, because xy to index formula. So py times the width of the PNG, right? And then plus the remainder, okay? So the number of full rows times the number of elements in a row plus the remainder, right? So that's the correct formula there. And then once we have the pixel index, we want to convert the pixel index to a component index. And so we multiply by 4 because of RGBA. RGBA equals 4, right? That's what the 4 is. So if we want to know what that magic number is, it's a 4 for RGBA. And you might be saying, why are you coding magic numbers like this? Because that magic number is never going to change. And so we just want to we want to keep the code as unabstract as possible. So my previous boss would be proud of me for not making some fancy define somewhere else for that, but I do a whole bunch of other crazy stuff they would hate, like probably this stuff here. But anyways, you know, take what you learn from different people and pick and choose what you like, you know. Pick and choose what makes sense to you. Okay, so this is our assert function, and we're just going to plus 3, right? 0, 1, 2, and 3 corresponds to this, so we're just doing an out of bounds check here, right? So out of bounds component index check, right? That's what that is. Okay. And then this is the actual the steps here. That's fine. I think that's good. Okay. So copy RGBA components and all that good stuff. And so you can see why we made like a little index up here of these steps, because now this is kind of sprawled out a lot, right? So this step here and this step here, if we highlight them, right, this, right, pretty big, right? And now we're in the push to texture section. So now I'm thinking we can just steal a lot of this code and use it. I think. I don't know. So okay, yeah, that's a good little check. Tau sync crash on get error. Okay, so we have like a little crash on get error. Do we want to keep that there? Sure, why not? So let's go look at that for a second. What does that code look like? Do we just want to copy it over as a little helper function? Yeah, it's not too much. So let's just throw it in this section, right? So all this is kind of supposed to help us write the code. So over here, we're just going to say void AAC 2020, and we'll call this Taudump crash on get error, right? So we'll get the exact same name because it does the exact same thing. And you might be like, well, if it does the exact same thing, why don't we just reach into here and call it here? Well, then we'd kind of destroy our separations of concerns, wouldn't we? So sometimes the code is repetitive, but there's a reason for it, right? So this stuff right here, we can just take this stuff and can just throw it in here, and then we can say, hey, crash on get error message, see above message for reason. So we might want to just make a note here that this is Taudump, or not. This isn't Taudump, is it? Oh yeah, it is Taudump. Yeah. So it's like dump ass, except it's for the Tau system, right? So we could do this. Also, this printf. Let's just do pf for printf, so that we can make this kind of shorter. And then maybe if we're lucky, no, we're not lucky. Let's just shorten that a bit, right? Since we're not directly referencing this code, we're free to change it in whatever way that pleases us, you know? So U32 air, the air equals GL bind, GL get air. So we're using our GL bindings. And that looks good to us. So the next thing is in our defines. So we have this assert, and then we're just say, you know, define COE as this crash on get air. All right, and that's number 7. So if we go down to the bottom of this section, we should say this, and then this will be COE, right? Okay. Okay. So now that we have this, maybe it's time to kind of clean things up here. And just say dash line I1x64, right? And then in other places, we can start to write these little divider lines between the different sections, so that when we look at this, we know where one function ends and one function begins. And you might say, well, you should know that just because we have the curly braces, right? Okay, blame my art school for the way I do this. Okay. So now, what do we have to do next? So the COE, okay. So the reason why we have the COE thing here is so that we can kind of like more easily cut and paste this. And it looks to me like this texture slot and texture handle was hard-coded, right? We're not going to hard-code that texture slot and texture handle. We're going to, it's going to depend on what that big kind of like CPU pixel thing was, right? So that means that over here, CPU pixel, so we'll just say text slot equals, and then text slot is this texture slot, or not this texture slot, but the PAINT5D texture slot, right? Okay. And then the texture handle equals, in this case, not the Taudump handle, but this is also the PAINT5D texture handle, right? And so we can copy these two parameters, right? Texture slot and texture handle. And this will be Taudump. And we might want to just make notes of this again, right? And just have all these close but wrong things, right? Because it's a big pattern breaker and it sucks, but so right, so if we try to search for this and we can't find it, right? Gpuview texture slot or texture handle. And that just sucks. That sucks that we have this kind of... It sucks that we have this kind of inconsistency where we have a GPU view that points to Taudump. So we have kind of like ugliness in our code, but sometimes you're just going to dig yourself into holes, man. You're going to dig yourself into holes, and now we're dug into a hole, so oh well. So PAINT5D for the texture slot and the texture handle here. And then over here, Taudump for the texture slot and the texture handle, right? So that also means that we need a texture slot and texture handle after this. So over here, we need to figure out, well, what are those numbers? And those should be uint32s. So uint32 text lot equals u32 cast of 0. Ooh. I changed my mind. We're going to do something like 0x ff FF, right? We're going to use it. So that's a trap value, right? That's a trap value to make sure we don't accidentally... I'm pretty sure the texture slot needs to be unsigned integer. That is why I am doing that. Now, I could be wrong. And we might want to look at not Taudump, but we might want to look at pixname and see if that's the case. So in pixname, in the data, U32 texture handle, int32 texture slot. Okay, so I don't know why I did it that way, but the texture slot is int32. Okay, texture slot is int32. And the texture handle is a U32. I don't know why I did that, but that's the way I did it. So that also means that this can be int 0 minus some type of bad value. How about that? There we go. That won't be looking like a coincidence if we see it in our code. We'll be like, that looks suspicious, right? And so the idea is we want this value to be kind of negative, so it's invalid, and also big enough where even if it accidentally gets casted to a positive somehow when it's used, it'll still be kind of out of range and cause problems. So we got these values here, right? So let's do this for a second. Let's close this. We took a look at that. Let's close C editor. We took a look at that. So this is the code we're trying to cut and paste, right? So here's where we calculate the correct CPU side bitmap and the correct parameters that we need in order to do our texture push. Down here, the first step is copy to CPU pixels, and then we want to push to the GPU texture, right? And we only want to push the dirty section, right? So ID, so 0182 time 0215 I don't know, how about 1515? That's amusing. Okay, we are only pushing the dirty pixels that were just overwritten on CPU pix by PNG pix, right? So we use PNG pix to paste pixels onto CPU pix. So this is the destination, this is the source, and we're only going to push those dirty pixels. So we're not pushing the whole thing, it's a subtexture push, right? That's the whole point. So we have some macros here. We kind of went kind of crazy with this. I'm going to try not to be as crazy. I'm going to try to just write this differently. So GL, I can see why I wrote it this way. Active texture, right? And let's just not write it this kind of confusingly, right? So let's just say, I can kind of see why I did that. Ooh, wait, we have a little thing here. We have our constants, right? So, AAC 2020 GL const dot texture 0, right? And then we're going to add an offset of the texture slot, right? So, I don't know where we want to put this. Plus text slot, right? I don't know how we want to write that, but we want to write it where it's kind of obvious. So AAC, oh, okay, also we're going to use COE right here. And just say... I don't know what the error message needs to be, but before we even start doing any of this OpenGL calls, we need to make sure that So identical messages, except this one's an A, this one's a B, right? It doesn't really matter what the error message is, we just need to be able to see it so that we can figure out what the heck we're doing. So then we have GL bind texture. So let's just say GL bind dot GL bind texture, right? So GL bind texture. And then we're going to use AAC 2020 GL const dot texture 2D. So this T2D should be for texture 2D. So we see GL constants dot texture 2D. So we're going to take this directly, right? Texture 2D. And then we're going to do plus, right? So the texture handle. Ooh, hold on, not plus texture. Sorry, not a plus this in this case. This is, it's not a plus, my bad. So the texture slot, the texture handle. Texture 0, texture 2D. Okay. What does this mean? So OpenGL is a big state pattern. So GL active texture is saying, okay, we have an array of texture slots, right? And depending on what texture slot is active, certain operations will use the state of whatever the active texture slot is to do operations that involve a texture, right? So we're going to say, hey, well, the active texture we want is this texture slot. And to compute that texture slot, the easiest way to do that is just texture 0 plus the relative offset, right? So this texture slot can be 0, 1, 2, 3, 4, etc. And then when it's just texture 0, right? So instead of using the constant texture 0, texture 1, texture 2, texture 3, etc., all those constants, we can do this plus the texture slot, and then we don't have to hard code things. It's a little bit more flexible. So then after we know that all the operations are going to apply to the texture slot that we want, the next thing is we want to make sure that of those texture slots, we can actually have more textures than texture slots, I think. I think that's what it's about. Because, oh, actually, no, I don't think that's, I could be quite a little wrong there. But basically, this texture handle represents a unique texture. And within a texture slot, you could have the same texture bound to multiple texture slots, right? So texture 0 could be pointing to this texture handle. Texture 1 could be pointing to this texture handle. Texture 2 could be pointing to this texture handle, right? So it's just a little bit of indirection, so that you're not required to, if you want the same texture in 2 different texture slots, you don't have to make them 2 unique bitmaps, right? You can just bind it to the same texture handle, right? Okay, so once we have this texture loaded into the active texture slot, we're ready, right? Because now we're definitely working with this texture. We're definitely working with this texture handle. And the way I do this is I want to avoid that kind of, basically there is a one to many relationship here, or actually is it a many to one? Actually, other way around. 1 to many, right? One texture handle can possibly be bound to multiple texture slots, right? We got this 1 to many relationship, and the way I'm writing my code is I'm getting rid of that 1 to many relationship, and I'm saying that a texture slot and a texture handle are always coupled 1 to 1 just to avoid confusion. So we're just trying to simplify the way we write our code. Anyways, so after we do that bind texture handle blah 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 stuff, we're going to do another oh no you didn't, but we're going to call this number C. And then we have a whole bunch of blah 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 debugging kind of stuff where we kind of figured out how the heck this works. And it took us a while and all this stuff here. So we might want to make a note here. This code is refactored version of. You might just want to make a note of this, right? That this code is a refactored version of If you want to see original commentary explaining how this the GL text GL text sub image 2D works, then go look at function. Okay. The time is 2 hours, 23 minutes, and 32 seconds. There we go. Like that. Okay, cool. So, yeah. So, if we want to know, like, why this code is the way it is, we can reference this, right? So, I'm making little footnotes. We can always chisel this. We can always strip out comments if we're like, man, we have too much commentary in here. And we can never add them after the fact. So, it's kind of like in wood shop. You can take wood away, but you can't add it. Okay, well, that's oversimplification, but it's even that analogy is even more true in this case. We can't go back months later and be like, what the heck was I thinking, and write the comments in, right? We can only write those comments, those thoughts we're having in the moment, and if we don't write them, they're lost to time forever. Okay, so let's go look over more of this code, right? So we have this alignment variable. So let's just steal this, right? So this alignment variable, are we using it anywhere else, or is it just kind of there? So it's just kind of there. And we have this uint array GC unpack alignment. Okay, so what we're going to do is we're going to say AAC 2020 GL bind dot GL pixel store I. And then we're going to do AAC 2020 GL const dot unpack alignment. So this UA right here belongs to, we're not going to use this hard-coded hex, we're going to use the unpack alignment because we have some tests to make sure that that value is correct. So we're going to use the unpack alignment, and then after using the unpack alignment, we see that we have this alignment variable, right? So let's just say, I'm just going to call it ALN like that, just so the alignment is 4. It's int 32. Let's just put the define. Let's just put it here. Alignment. And then we can put it over here as well. Oh, I see a typo. Alignment is 4, right? RGBA. 4 bytes per component per pixel. 4 bytes per pixel, that's why the alignment is 4. As far as I know, I could be wrong, but it works, so... and I did a lot of reading on this, right? So, will only work... GL RGB will only work for all cases, including odd row widths, so simply use that. Okay, yeah. So, I'm pretty sure that's why that's the case. Now, if someone wants to correct me, I'll be more than willing to be told what the heck I'm doing wrong, because I'd rather be smarter than stupider, right? So, okay, so we got this alignment, right? Pixel store, unpack alignment, the UA. And then once again, we're just gonna run this, right? We're gonna be very paranoid about this, and we're just gonna say, oh, no, you did it, number D. Okay. And then after that, we see, oh, we have this text subimage stri.txt. Sure, we can keep that in the notes, because maybe that document still exists, and maybe it would be helpful somehow, right? So, this thing, right? Ooh, we got that wrong. Well, hold on. Oh, same command, but the command does something different. It's like a... It's kind of a command pattern, right? It's this function, but what the function does depends on the first parameter and then the data, right? So this is the... What do I want the function to do? What is the data that I'm going to supply to it? So this URL thing unpack row length. So what I would like this function to do this time, right, is AAC 2020 GL const.unpack row length, and for that row length, blah 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 stuff, what do I want to do? URL, let's look at that. So we're just trying to get rid of some of this indirection. So this PW 512, it's the pixel width. And instead of using 512, maybe in this case we actually want to use the CPU width, right? CPU width. And in that case, that would probably make more sense. So CPU width, and then also, why do things not look quite aligned here? Oh, because this needs to be... Okay. Everything looks nicely aligned. Okay, and then once again, if something goes wrong there, A, B, C, D, E, and let's go find where this PW is coming from, right? So this PW is right here. We got some clues, blah, blah, blah. So this is the prep, right? So this is the prep. So we might want to label this section. So we want to keep that same kind of section name, right? What are we doing in here, right? Oh, we're prepping. We're prepping to make that call. So maybe we would like to make a note of that, right? So this is prep. And then after it's prepped, oh, look, texture 2D, blah, 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 blah. That's all good. Now, do we have some tests in here to assert that these kind of random things that we've kind of inserted here are correct values? Because this is kind of brittle, right? You shouldn't use such internal stuff. Yeah, that's totally true. So what we're going to do is we are going to reference these from the GL constants, and if they don't exist in the GL constants, then we will make them in the GL constants, right? So we're going to try to, we're basically rewriting this code and making it better than it was before. So text sub image 2D. So this is going to be text sub image do it, right? So the first part was the prep, and now this is the actual, you know, actually do it this time. And I did choose do it because it's 4 letters and prep is also 4 letters, right? I did do that intentionally. Now, I would like to indent this one more time, but I'm kind of out of room. I'm out of room to indent this anymore, and I already like the kind of spacing I have because we have these kind of parameters right here. It just kind of all fits together very nicely. I'd like to just keep it that way. So we'll just not indent these scopes, and they're not really scopes, right? They're just sections of what's going on with this code. But we're just running out of column space here. So in here we got this offset to first byte, right? And that offset to first byte is over here as well. So we could take this and put it in here. We could put it directly in there. I'm not going to. You know what? Let's just keep it like this and say, you know, in 32, offset in bytes. Okay. So we'll make a note of this, right? We'll just keep it here as like this, right? So this thing Oh, hold on. Offset in bytes to first byte, right? So we're going to just steal all of this, right? Now the thing is that we already know what we're doing this time. So we got this x0, y0. We don't need this PBR because it's already there. Now the thing is, why do we have this multiplication by 1? Like, what the heck is this about? Because I'm seeing this multiplication by 1. Oh, because we're not doing anything to it, right? It's a multiplication by 1, not an add 1. So that's just to say we're not multiplying it by anything. We're not changing it with the multiplication, but this is getting changed because y is the remainder, the stride, right? So, okay, that makes sense to me. So let's do this. This is in its own little scope. Index XY formula? Yeah, it is index to XY formula, isn't it? Yeah. I just realized that. Okay. And we're going to take this, and then we're going to times it by right, so we times 4 to get the component index. And now you just need to delete some of this stuff, right? So we've just written it slightly more compactly, right? Offset in bytes to first byte. Can we just kind of like do this? Ooh, not quite. Well, we could just do this. We could just say, you know, int32 OIB TFB. Right? We could do this. And then now we kind of can. Ooh, that's still kind of ugly, isn't it? Also, let's just make a little scope here. Why not? Make a little scope. So nothing should escape from here. Which we did that over here, didn't we? In this first step. In this first step, we kind of made like a little scope. In this step 1, in step 2, we have a little scope again. Okay, sure. And okay, and then GL text subimage, whatever the heck. Right. Okay, and then AAC 2020 GL const dot. We're gonna take this texture 2D, and then we're gonna do the level of detail, right? So, do we want to just kind of keep the same? Level of detail, right? Do we want to just write it like that? I mean, I'm not against that. Sure, level of depth. Sure, why not level of detail? You know, we tried not to write a whole bunch of macros, and then we just changed the macros. Level of detail is always 0. So down at the bottom, we gotta make sure this is undefined. So undef levodap. Okay. And level of detail is 0. Okay. And then, holy crap, this is actually the call. But there's so much comments in it that we didn't realize that this was not a... Yeah, it's the GL subtext image call. What am I doing here? That means that this actually needs to be kind of broken up a bit. And we should probably do... We should probably not write it the way we just wrote it, right? We should probably write it like, right, we should probably write it more like that, right, with the lax comma style. And so now we see these parameters. We have this x0, y0, x1, something or other. So we're going to take all this. So this is the dirty sub-selection rectangle. That is actually still true. But this PBR, whatever the heck, we're not doing that, right? We're just calling it rec this, right? It's called rec. Because instead of giving it a struct, we're just giving it the raw coordinates. Okay. And then let's kind of move this around. Okay. And yeah. So the width and the height and the top left and, sorry, the orange left, the orange top. Oh yeah, top left is the top left. Okay, I see what we did there. Okay. So the +1, why is the +1? Oh yeah, because off by ones for the width calculations. Format of CPU data. Do you want to keep that in there? Do we want to keep this commentary? Well, we already know that if we really want to see the full commentary, we can reference back to this original function we were copying from. We even made a note about that. So I'm going to make another note. I'm going to say CPU picks in picks name have this format. So CPU pixels in pix name have this format, right? So I think that's a better comment because it kind of tells us like why is this the format, right? Basically RGBA integer textures, right? Basically RGBA integer textures, right? That's basically what that is. And then over here we can write kind of this craziness again, but what we're going to do is we're going to say CPU picks, right? So we're not going to have that hard-coded. And then 0 plus offset in bytes to first byte. So OIB TFB, right? And then we can also just keep this commentary here, right? So we could just keep the commentary for that original name, right? So the idea is terse code and verbose comments is kind of how I like to do it. So you can keep that same offset in bytes to first byte, but we can make that a comment rather than the code. And that looks pretty good. So this is the actual call. Finally, the actual texture, the actual call. So finally, we get to the, we get to the actual call. God damn it, what the hell? Copy. I keep on trying to press Control V and then I press Control Copy there. Okay, so yeah, this is good. This is good. This is what we want. This is the actual call that we're trying to do. So if this glconst doesn't exist, we'll figure it out. I think it does. I think we already have it right here. Yeah, it's already there. Was there anything else that was hard-coded that we didn't want to hard-code? So RGBA integer. Oh, wait, RGBA integer. Same thing. This needs to be glconst. My bad. glconst. Right? So source format and source type. So src fmt and then typ, right? typ. Source format and source type. So if we want to make a note of that, right? If we want to go into our documentation, well, if we do that, we have to make a note of it, of what that is. How at s fmt like that, right? it's more terse, but if we really want to know what that means, God, I hate that. But we're just running out of room. Format and type, source format, source type. Sure. So in our documentation, we can just say, hey, if we see this, just know what the heck we mean, right? So for these two things, we can paste them here. We can cut this out. We can put it over here, right? So at src fmt source format at src typ at src typ source type 0182. The time is 02:43 and 02. Oh wait, 44. How about we just wait till 14, because that would be somewhat amusing. 04414. Sure. So the source format and the source type, so you know, if we just wanted to write a shorthand comment so we know what that original comment meant. What it is kind of cryptic. So it's kind of like, if we really want to know what that is, we can look at it. The idea is that if we're smart enough and we know our OpenGL code well enough, we'll instantly know what these abbreviations mean, because we know what these parameters are supposed to be. But if we don't know these, if we don't intimately know the signature of GL text sub image 2D, if we don't know it well enough, then we won't know what these are. But these will be like little clues, right? To where once we know the API well enough, it'll just be obvious what that is. So okay, that all looks pretty good. So there's our texture pushing steps. And oh boy, is that not a big kind of like helper function, right? So that was the reason why we wanted to not directly use this, because there's a lot that kind of has changed, and we also kind of cleaned it up a bit. Okay, so now notice that this is the public function, right? So this is the public function. So first of all, let's take this for a second and make a note. Public functions. So we want to keep the commentary as well, right? Like this. First of all, we could instead of calling it width and height, we can shorthand that a bit. Also, that's U32 array. We got that wrong. Let's go over in the commentary over here. U32 array, U32 array. My bad. And texture memory to paste to, commentary, right? So we just want the public functions. So let's just call this pixWidth. Actually, let's just call it pix. We already know pix means the width. So width. Yeah, sure, why not that? And alright, let's just kind of write it so that we can kind of like, this is the public function that we care about, right? So let's go back down to where we're writing this and figure out what are we missing, what's the next step. that we need to do. So CPU pixels is here. Okay, so we're kind of ready for that call, right? So if we think about what we did here, like in the terms of these steps, what is this? What is the kind of first step here, right? So the first step is... Okay, yeah, I see. Now, is this in a loop? What are we figuring out? I guess this is step one, is figuring out what to paste where. Right, this whole thing right here is step one. So step one is figure out what to paste where. Now I was told when I worked at ArenaNet not to label things as step 1 or 2 because that might change. Yeah, if it changes, just change the comment, right? It's not a big deal. Think about it. If you write a million lines of code that have step 1, step 2, step 3, right? That have those kind of steps, right? Or there's a million different functions that you've written over the course of your history, right? And you've labeled them. The function bodies all have step 1, step 2, step 3, step 4, etc., right? Okay, well, let's say you've decided to change all a million of those functions and add different steps in them. Okay, well, the problem you have on your hands is not that in the comments you've labeled things step 1, step 2, step 3, and now those comments need to be changed. The problem on your hands is that you have a million functions that you've decided to change the behavior of, and that's a hell of a lot of work, right? So I don't agree with not writing things out as steps, because if you are constantly changing all of the functions you've been writing all of the time, then you have absolutely no time to steam ahead, right? So we want to write it. We want to write it once, write it well, and then hopefully never have to come back to it, right? You know, worst case scenario, if we have to come back to it, we'll just rename the comment steps. That'll be fine. Okay, so step 02, call helper to copy, paste, and upload. That is kind of a big kind of name, a big kind of category section, right? Where it has like it's a little bit much, right? Oh well. So let's do a clipboard stack right now. And let's copy step 1. Let's copy step 2 and do kind of the same thing we're doing. Ooh, my bad. Let's copy step 2. And then up here, let's just do a CS dump. Right? We got step 1, step 2, and then let's kind of like just do this again, right? And it's like, man, you're spending like, what, 2-3 hours on 2 function calls? Yeah, I am. Because I'm doing C code, I'd rather go very slow and deliberately than to make a cluster of spaghetti code and then not know what I'm... Yeah, I don't want to make a cluster of spaghetti code. I want to know exactly what I'm doing, exactly why I'm doing it, and make some very solid, rigid code. So 53 minutes and how about 23 seconds, right? Keep with the conspiracies. Okay, so yeah, step 1, we want to figure out what to paste where. Step 2, call helper to copy, paste, and upload. So if we remove the token highlighting, we can kind of color code these sections really quick. So we can kind of jump to where we want to look at. So we got this stuff, and then we have this helper function. So the helper function is this kind of function we wrote up here that kind of is craziness. Yeah, so we're going to take this helper function. Actually, we're going to take the whole... We're just going to steal this, right? We're going to copy-paste. We're going to do some duct tape coding with our own code. And right down here, we're going to paste that. And some of these variables should already exist, right? We should have already figured them out. So this is x0, y0. Okay, so that is... Right. Alright, so we've created a rectangle, but in the code we just kind of like kept the... we didn't name it rec, we just named it the bounds, right? So these should all match kind of up right here like that. Bam, right? They all match, right? Okay. So then also we have the PNG pixels, which, where are they? Are they in here? So, actually no. Because we have to uncompress the data. So we got to change the steps. So step 02, uncompress PNG to byte array. Okay. And that also means we need to free that memory, right? So this step 2. Oops. This step 2 that we're going to uncompress. Okay, then we're going to do step 3, right? Call helper function to copy, paste, and upload. And then we have one more step we need. And it's good that we can just write it in here, right? So we have a step 4. Free uncompressed PNG bitmap data. Right, that is kind of, these sections are kind of ridiculously, this is a ridiculously verbose section, but, right, we want kind of like a one-line summary of exactly what's going on in this section, right? So, we want to free, and we should just be able to free PNG pics, right? And then we should say that, you know, PNG pics equals UO8 pointer 0. So we're freeing it before it even exists, right? And that is intentional. Also, let's just assert that UO8 pointer 0, right? Oop, so U8 pointer cast of 0. God damn it. Is not equal to let's kind of line this all up. So, right, we want to make sure that we're actually not trying to free a null pointer, because it should have already been assigned to something, and if it's not, then we have a problem on our hands. And then PNG pixels is going to be set equal to this kind of cast. So, I don't know. Sure. Okay, yeah, so it's kind of a lot of work to, you know, free the uncompressed thing, right? It should have just been this. Like, if you are kind of writing your code kind of slow, you'd probably just write this. But we want to be careful about what we're doing. Okay. So then the next thing is, okay, we want to uncompress this thing here, right? And to do that, there should be some way to create the PNG pixels, right? So, so PNG pix. Oh, actually, let's write it some function. So we know there's some type of function and some type of thingy it takes, and then one of the outputs is going to be the PNG pixel, and then another one of those outputs is going to be like the PNG width, and then another one of those outputs should be the PNG height. Like, if we know what we're doing and we have a consistent style, then that should be pretty close to what we need to do. And so where would that be? Well, let's go look in our code for a second. Let's go look at this kind of system here. And if we look at the system, we can kind of guess, right? So we have, it's asset dumping, right? So it's dump ass, which is probably responsible for it. So this dump ass is probably what is responsible for... Oh, no, dump ass dumps the assets, loads pixels from executable memory. Load pixels from disk. Oh yeah, so this is what we want. We want loading the pixels from the executable memory, right? Because we have an asset that's hard-coded into the executable, and we want to do a dump of it. So, okay, so I was correct. So dump ass. So we're going to open this up and find the function that we need, right? So in here, dumping assets into cal-locked memory. Oh, hey, that sounds like what I want. Okay, so we got dump ass, PNG. Okay, so these are very specific helper functions, aren't they? Dump ass PNG number 1 into pixel array. Yeah, these are all very specific cases. So we might want to use PNG hex number. Now let's take a look at this and see kind of like how we've designed this. So we want the U32 array. So we want the PNG pointer and we want the number of elements. Okay? So if we look at this, here's the PNG pointer, here's the number of elements. So what we really want is this part. So we really want to just steal... I want to steal all this. I know I've stolen this before, but this is what we want. So in here, let's paste this for a second, and we'll probably notice that we got most of this right. All right, so this thing, pixel array. Oh, the pixel array, the pixel width. We're not going to keep this part. Okay, this one here is So all these things here could be differently referenced. Pix width and pix height is already in here, right? So this pixel array this is not correct. So this is a this should be, and probably the number of elements is probably int32, right? So U32 array, U32 number of elements, I'm pretty sure. Okay. And we can just comment this out, right? Because this is already set, right? Pix width is already set. Oh. Oh, I see. Okay. I see. Change that back. So this is the actual width, right? The actual width and the actual height. And here's the pixel array, right? So we're going to do the actual width and the actual height. So pix width, pix height, and here's the pixel array. The pixel array is nothing right now. It's a U8 pointer that just points to nothing right now. And so this is a pointer, right? And so this is hard-coded right now, right? So okay. And U32 len example, right? So we'll take these examples here, right? But these examples here, U32 array and U32 len, number of elements, right? And that makes sense because so we might want to make a note here, right? That sometimes we have multiple names running around in our code, and it sucks because our code isn't quite normalized. But U32 array, U32 len slash U32 number of elements, right? So U32 array could also be thought of as U32 pix. Could it? Right, there's plenty of things that we might call it accidentally. But the U32 array is here. Now, this is coming from way up here, right? So so we have an example here, right? But then over here, does this example make sense? Oh yeah, that's still just another example. All right, so two different examples. That's fine. Let's call this U32 number of elements here. So that way when we highlight both of these, when we highlight both of these, we can see kind of like the two examples up here. We can see this example and that example. And then down here we can see the examples here as well. So we got the pixel array, we got the pixel width, we got the pixel height. And it would be good to note that Do we have, for these hard-coded assets, do we have the correct types? So yeah, the number of elements is signed, while the data is unsigned. Yeah, that was correct. So, right, so the, so if we look up here, right, the number of, oops, wrong code. If we look up here, right, the number of elements right here is assigned value, right? And the actual array of data is an unsigned array of uint32s, which encodes a PNG file. Okay. So that looks good. So PNG hex dumper, we're actually going a little bit lower level. I thought we'd use the intermediary function, turns out not. And for this, pix width, pix height, is this true? What is the pix width, pix height? Is that what it should be? No, so the pix width and the pix height right here is what we're declaring it as, right? So this is the PNG file, and this is what we're expecting it to uncompress as. So we already kind of know the size of it before we even use it, right? So if the wrong sized asset was encoded, then we know, right? So what we're going to do here is, you know, if 0 or actual width not equal to PNG width, right? We call it PNG width, I think. We look up here, we call it pix width. God damn it. So PNG width is where? Nowhere, because this was just some junk code I wrote. So act width is not equal to pix width. Or the actual height is not equal to the pixel height, aka PNG height. Okay? Then what we basically have is wrong asset size was embedded likely. So that's probably what happened, right? So let's make a note of this. 03, 10, and 32. Sure, why not? Or not, because we screwed that up, so let's just call it 42 to be cool. 03, 10, and 42, right? So if this error happens, it's likely that we encoded the wrong asset size, right? So we're expecting to do some operations with, say, a image that is like 64 by 64 pixels, right? But then when we take this hard-coded image, this hard-coded PNG file, and we deflate it into a raw byte array, the PNG decoder library reports back a different actual width and actual height than what we declared it as. Well, that probably means that the wrong asset size was embedded likely. Wrong asset used. So I think the most likely problem is that we're using the wrong asset, right? Problem 2. Then we have another problem. Problem 3. Correct asset, but wrong size. So there's like a maybe 1, maybe 2, maybe 3, right? So maybes. We'll call them maybes, right? Because these are the things that might be wrong, right? Maybe this is wrong. What's the most likely thing? Wrong asset size was embedded likely. So I think the most likely mistake we're going to do, maybe you supplied wrong asset to func. So I think the most likely case, error message will be what I think will be the most most likely mistake I will make. So it's error message correct, but my best guess out of the pause. Yeah, so the error message here that we're seeing here is not what is actually wrong. It's what we think. If I make a mistake, I'm thinking that that is what the mistake will be. However, it might not be that mistake, right? So we're gonna change it to 42 because we want to be cool. And then when it hits 42, we'll explain it one more time. So right here, oops, right here, let's explain it one more time for the camera. This message here is the most likely mistake that I'm going to make, or at least the most likely mistake that I think I'm going to make is supplying the wrong asset to the function. So right up here, what I mean by that is that in this function, I think I'm going to supply the wrong values here. That is what I think is going to happen if I do this wrong. Now, there's other possibilities, right? So maybe the wrong asset was used, maybe the wrong asset was embedded, or maybe the correct asset was used but was the wrong size. But I'm thinking this case here, supplied the wrong asset, so this would be maybe number 1, wrong asset use. So I'm just phrasing it slightly differently, but it's the same scenario, right? So if the actual width does not match the expected declared width, okay? Actual width, actual size should match declared size. Okay, so that's what's going on here, right? And we want to make sure that width is matched up with width and height is matched up with height. That looks good. Okay, cool. So the other part is that this looks like we have too many brackets here. I don't know how I made that mistake, but okay. So we're in step 2, uncompressed PNG to byte array. So with this PNG hex dumper, right? We're going to take these compressed assets, right, the actual PNG files that are in the executable memory, and we're going to deflate them into this pixel array and get the actual width and actual height back. So this pixel array right here is the thing that we need to free. So we said PNG pixels here, and we're wrong. PNG pixels is the AKA. PNG width, same thing. So these things need to be changed. So we're just going to say pixarray slash so this is actually pixarray. This is pix width. This is pix height. And then also we don't need these right? We cut and pasted. That needs to be fixed. Dex Eddy. Do we have Dex Eddy supplied in here? Did we remember that correctly? So let's go look at Dex Eddy. That should be like right in... No. Taudump subsection. So that just should be hard-coded, right? Because we're going to dump it into the Tau. So if we look at Tau Depot, right? Tau Dex is this first kind of thing, and then once we're inside here, oh, okay, wait, hold on. Dex Eddy is not really the best thing there. Oh, it identifies the CPU side bitmap. Okay. Oh, I see. Okay. Not the best. I get why I did that, but it's not in the same... I get why I did that. So if we look at Dex Eddy for a second, identifies the CPU side bitmap, excellent. And then, yeah, that just tells us which kind of memory that we're going to paste into. Okay, got ya. So now that I know that, and I'm trying to use this Dex Eddy, let's just say, you know, int32 Dex Eddy, and Dex Eddy equals, are we just going to hard-code this to... Are we going to hard-code this? I guess we're going to hard-code it because it's Taudump, right? We're dumping into the Tau, right? So... actually, let's define it. Or not, I don't know. We are in Taudump, so the memory block we are okay, so it should always be this, and to identify that, if we go into a current editor, to identify that memory block, identified by Gpuview, which kind of sucks. Because Tau Depot is not a name of a editor, unfortunately, right? We wanted a one-to-one name. We wanted a one-to-one relationship between editor names and memory sections, except Tau Depot kind of breaks that convention, which kind of sucks. So we are dumping. We are in the Taudump. We are in Taudump, so the memory block we are dumping to should always be always be identified by I think that's correct. Boy, did I spell identified that wrong the first time? Yeah, I guess I did. And so it's not this one, right? So it's not ceditor tau depot. So we're going to make a note of this. So if we ever search for ceditor tau depot, right, we're going to find a not. So if we look for it and we can't find it, we'll hopefully know why. Now, the way we formatted this code, let's just put in a big multi-line comment so that we can actually have enough space for this. Okay. And this big comment actually is applying to this comment right here. So this is the memory that we want, and we're going to identify it by this enumeration. So we want the memory for this certain editor, and that is a little bit weird because we're going to use the Gpuview. The editor is Gpuview, but we're doing it to update UI rectangles. That is kind of convoluted. Let's just wait for 42. Kind of convoluted, right? Unfortunately, kind of convoluted. So we should... Okay, so let's explain this one more time for the camera. Okay, because this is convoluted as heck, and I wish it wasn't. So this dex editor, right, is an enumeration that identifies memory that's associated with a certain editor, right? We're trying to make everything very editor-centric. So to identify the memory, we will use the Gpuview enumeration. Unfortunately, unlike most editors where there's a one-to-one relationship between the name of the memory block and the name of the editor, Gpuview is not like that. So Gpuview is associated with the tau depot memory block. So pix name tau depot CPU pixels. So this name here is going to identify tau depot's memory, and that's the memory that we want to edit here for Taudump, right? Because Taudump is going to dump stuff into the tau depot memory, but to properly identify the tau depot memory, we have to use this, right? So, so once again, right here, it's not AAC 2020 ceditor tau depot. Yeah, whatever. We had the big multi-line comment for that. Yeah, but this is right. There should be something like this, but there's no tau depot editor. There's a Gpuview. There's a Gpuview editor that can look at different memory subsections, right? So there's a one-to-one relationship between most memory blocks, except the Gpuview editor is special, and it can inspect any memory. And that's kind of why tau depot was never meant to be... tau depot was never meant to be referenced. And now we're referencing it. That's kind of why everything's kind of like a little bit ucky. Okay. God. Okay, so anyways, it's got this editor index, and these things need to be changed. So PNG pixels, PNG width, PNG array. All of these are, right, we had these AKAs over here. So here's the pixel array, and then we have a pixel width and a pixel height somewhere. We have a declared pixel width and a declared pixel height there. So we want pix array, and then we want pix width, pix height, right? So this is uncompressed PNG byte array, right? So that's what this is, right? And this right here is selection destination paste coordinates, right? So that's what this is. 512. What 512 by 512 memory block to paste to? Right, so we can kind of identify what all the different parameters are. We can kind of like indent that properly. All right, so this is the helper function, right? So this is the private helper function, right? So you can see we're inside copy the call helper function to copy and paste and upload and all that stuff, right? And then once we've done the copy paste upload, we want to free the pixel array. So it's not PNG pixels, it's pix array. And then, you know, also we should say, you know, pix width, and it doesn't really matter because we're going to exit the function right now. But we might as well zero out these values as well. And then we might as well assert right here. I mean, it's already too late if we've already screwed this up. We want to assert that pix width is greater than or equal to 1, right? And we want to assert that the pixel height is greater than or equal to 1, right? It needs to be at least 1 by 1 pixels, otherwise we don't really have much of a pixel array now, do we? So now freeing the memory seems like a very complicated ordeal, right? And we're getting more complicated than we need to be, but we're just adding another level of safety, right? So the verbosity we have here is just to be very paranoid, very safe here. So this pixel array, where are you coming from, right? So if we look at pixel array, here it is. This is where we're pushing it, okay? And pixel array here this is where we're getting it, right? So it starts out as a null pointer, and the width and the height start out 0, so they start on the zeroed state, and this function here is going to expect the output parameters to be in an invalid zeroed out state before it fills them. So it's going to do some error checks to make sure that's the case. Otherwise, it's going to say, hey, I think I might be overriding some valid memory, and it's going to crash, okay? So once we've uncompressed the encoded PNG file into an uncompressed array, these will be our output parameters. Once we have these output parameters, then we're going to use them to push up to the texture block on the CPU side, right? And not only will we push it up to the texture block, but we will also we'll copy the CPU side bitmap and then push up the dirty subsection of that CPU side bitmap to the corresponding GPU side texture. So that's just a complicated way to say we're going to update the texture by cutting and pasting the pixels from the entire embedded asset to some location within the texture, right? So we're just going to update the GPU side texture with the hard-coded asset. That's all we're doing. Okay, so now this helper function, let's make sure this helper function looks correct to us. So if we go in here, okay, because we got this rectangular area. Okay. Same thing with this. This would be a more... Okay, these would be more descriptive, aka PNG height, also known as pix height, right? Pix arrays height in pixels. Right, so that's a better commentary there, I think. Pix width and pix height. So now let's just look at these and make sure that these parameters are correct. Let's clean that up a little bit. Okay, so we got a lot of craziness in here. And it's kind of scary, because it's like, how am I gonna assert that all this is correct? Well, we have the texture memory inspector for that. We could try that. Okay, and we also have some other assets that we want to put in here, right? So, oh, this is Taudump, which means Taudump hasn't even been put into the project yet. So, because it's not even put into the project yet, it's probably not even going to do anything yet. It's not going to... We've written a lot of code for it, but it is not included in the project yet. So, so Taudump, we're thinking Taudump should be really like a data-only thing. So, Taudump.d, no data, only functions for Taudump, right? No data, only functions for Taudump, right? It's just kind of a utility class. So in here, Taudump.d._. So we still want to keep to this pattern of every single subsystem has a data file and a function file, even if there's no associated data, because eventually maybe there will be, but for consistency, we just want to do this. Now, we always reserve the right to change our mind, like maybe we want some debug flags in here or whatnot later, but for now, that's fine. So dump_ass, for dump_ass, we did change this as well. So we kind of just cut and pasted a whole bunch of code to make a dumper that's going to dump the UI rectangle data. And we're going to, right, so we're going to take this. And, okay, so this is what kind of allows us to extract this data here, huh? But I don't think that's the way we did it in here, is it? I think we used like a helper. Yeah, we didn't use a, we used a PNG hex dumper directly, didn't we? So what's the... Okay, so the pro there is that we wouldn't have to, we could just, use this directly. Okay, I see. So this isn't used anywhere, is it? Yeah, it's not used anywhere. We might want to make a note here. So we took all this time to like make this function, right? Cut and paste it. So let's make an error here. Error. Never used. Use at your own risk. Right, so let's make an error in here and say at vid IID 0182, time is 0336 32. We used used instead. Might want to write a unit test for this. Right, so this is not being this function right here is currently not being used anywhere, right? And the thing we used instead, right, if we go over here, is we used the U32 array to pixel array, right? So we kind of directly grabbed at what we wanted to rather than using a wrapper function, right? Which is probably a better way to go about it anyways. So we used this. So so this is what we used. And then over here, we might want to say, could have used let's just call it alt way for alternative way. So an alternate way, or alternative function, right? So an alternative function we could have used was this, and if we use this function instead of this function, then we wouldn't have to supply these two parameters, right? Now the reason that we didn't do that was because it's a little bit more flexible, right? We can actually supply what that's in there, right? So instead of alt function, actually, I just say not fun, so I just want some reference for where I was considering using this function after I coded it. We'll just keep that function in there for consistency, and yeah, that's fine. That's fine, so we have some weirdness in our code, that's fine. Okay, so yeah, so this was never used, right? We made all this kind of hula whatever the heck. But we used this instead. That's fine. So Uirects is going to have an initializer code where it's going to use it's going to use, not this, this is the helper function. Oh, we're in dump ass. Okay, so over here, my bad. So in Taudump, Taudump subsection. So, do we have a UI frags yet? Oh, no, we're not going to do UI frag. So this is the fragment shader code, tau frag. Almost made a mistake there. So tau frag. Wait. No, this is helper code, right? Yeah, that's helper code that uses tau, right? It's like generic. So tau frag is like fragcom, like fragment shader common code, but it is yeah, similar to fragcom, except manages access to tau depot memory from the shader code. Yeah, so tau frag is not what I want to look at. So, user interface recs. So, Uirects is going to be the user interface fragment code, but it's going to need the Uirects data, right? So I know that kind of we're separating things into kind of like more pieces than it needs to be, but whatever. So let's go open up Uirects. So Uirects. And that should have like an initializer function, because I knew I needed to initialize data for this. Right, so hey, look at that, bitpacked glyphs. So there it is. And note that, hey, I said that I wanted to bitpack this, didn't I? So this Taudump subsection thing, we need to add another parameter into here, right? So in Taudump subsection, we have the dex, the sub, selection area, but we also want to specify a bit channel, a bit dex. So we have a tau dex, a sub dex. In some cases we use a var dex, but in this case we want a bit dex. to encode in. So what we're going to do here is we're going to give it this other parameter, right? U08 bitdex. Bit index to write to. Int 32. And U08 use 1-bit color. Do you want to use 1-bit color, right? Copy paste using 1-bit color. Black pixels become 1 bits. Any other color becomes okay, black pixels become 0 bits, sorry. Right? So copy paste using 1-bit color. So use 1BC for use 1-bit color, and then int32 is the bit index, right? And so if use 1-bit color is not flagged as true, then the bit index has no effect. And then it also means that we're going to have to pass this on to the other function. So if we go down here, right, we have this like crazy, we have a helper function somewhere, right? And so this GL text subimage 2D, if this is what we want to do, then use 1-bit color. Okay, and bit index to paste to. So if we're going to use 1-bit color, this is the index we're going to paste to, right? So then in this helper function, we have to do this over here as well. So we kind of have to forward it through here. And now this is like a crazy helper function, right? This is like ridiculous, right? So this right here is going to be U08, right? Because it's just a flag. And it's use 1BC for use 1-bit color. Right, use 1-bit color. And if that's the case, for using 1-bit color, bit index to paste 1BC2, right? So if we are using 1-bit color, here's the bit index to paste to, right? Okay, so now that we have that, we just have to modify our copy-paste algorithm, right? So we have this code over here, right? And to keep it simple, if use 1-bit color is not on, right? Then we'll 1, 2. That's kind of ugly, but oh well. So now we're nested way too deep, and I hate it. Else, if use 1 BC, let's just say 1. Let's just force it to be 1 or 0. Make it a Boolean. One bit color, otherwise 32-bit color, right? 32-bit color, 1-bit color. Else, we have an error, bad Boolean given, 2021 0316. How about Taudump? Okay, so for this 1-bit color, this is, and I don't really like this because now we have multiple code execution paths, which is not ideal. And this is a little bit too long, right? So we're gonna have to be more cryptic here. RGBA, right? Which, if you're doing a lot of graphics programming, RGBA right here should be kind of obvious as to what we're doing. So, how the heck, what are we doing here if we're doing this kind of 1-bit color here? So, we're gonna save, first of all, we're going to extract the original pixel, right? So we're going to extract the original pixel. So 0x00, right? And we're going to OR it together with this shifted 24, 24, 16, 8, and 0, right? So network byte order, R, G, B, and A, because the network byte order, right? And we're just going to paste them into the positions where they belong. Okay. So we got this U32 pixel. Now, is U32 pixel anywhere else? AKA U32 pixel. We'll call it 1 pixel, right? 1 pixel. So we're going to extract the 1 pixel, and then once we have it, extract 1 pixel. Steps. Step 1. Right? So we have 3 steps. Extract the pixel, change one of the bits, put the pixel back, right? Oh boy, we're writing way too much code. This makes me nervous. Okay. So let's change the pixel. So 1-bit color, we have a pixel index, right? So, you know, assert that pixdex, or do we call it pixdex? No, we called it like a bitdex, right? Because in here, right, it's called bitdex, right? Because it's the bit for the 1-bit color. So we want to assert that bitdex is greater than or equal to 0. Okay. Assert that bitdex is less than or equal to 32 32 minus 1. And then also for consistency, or not consistency, but just because I'm OCD, there we go. Maybe we want to put this minus like that, so that we get the proper syntax highlighting, because our syntax highlighting is kind of weird. Okay, so we just want to make sure that valid index for 32-bit pixel. Okay, is it a valid index for a 32-bit pixel? That's all we want to make sure of. And then we're going to just say this 1 pixel equals. Actually, how about this? New pixel. So the new pixel equals. We're gonna say. We're gonna take the 1 pixel, right? And we're gonna mask it with a 1 shifted over by the bit dex. So we're gonna let's say a U32 eraser. Beraser. Bit eraser equals 1 shifted over the bit dex and then knotted, right? So we're going to take that and then we're going to flip the bits, right? So it's going to be a mask where everything is 1 except for that 1 bit, right? And a bitwise knot is either this or that. So hold on. C99 bitwise knot. Oh, can we just do it? What the hell? That doesn't look... I kind of remember what that was about. I feel like that's not a knot, that's like a XOR. C99 bitwise knot. Yeah, bitwise knot is a tilde. Maybe I'm looking at the wrong language. Bitwise and, bitwise or, bitwise not. Yeah, that's what I thought. Okay, bitwise not. Bitwise complement operator. The tilde flips every bit. A useful way to remember this is the tilde is sometimes called a twiddle. And a bitwise complement twiddles every bit. If you have a 1, it's a 0, and if you have a 0, it's a 1. Okay, yeah. So it is the tilde function. So I'm going to go and put that in my notes really quick. So next time I do this, I don't make that mistake. So let's go up here, and we want to say C99 bitwise not, C99 bitwise not, C99 not, okay, not C99, bitwise not C99, and then bitwise not C99 and bitwise not C99, or bitwise not C99, or C99 bitwise not, or C99 bitwise not, all is like a one-worder thing here, and it's just going to be tilde. I'm just going to do that because I don't know if tilde is kind of like a special character, and so AutoHotkey script is probably not going to like it if I try to use that. Okay, so now that we have that, we know that for the bit eraser, we're just going to tilde that, right? So we're going to take this thing, we're going to shift the bit in position, and make a bit eraser, right? So we also might want to make a note of, well, what beracer means, right? So beracer, U plus bonds hexa, so we typed it correctly. But then we might want to know what the hell we mean. So bit eraser, bit eraser, bit eraser. So for bit eraser, beracer. How about beracer snip? Bit eraser snip. Bit eraser snip. Eraser snip? Sure, why not? C99 bit eraser. C99 bit eraser. Bit eraser C99 or bit eraser C99. Okay, so those are all kind of things we could type. Also, let's just do bit eraser C99 like that. Okay, so for the bit eraser, right, we have the code for that, or at least we think this is what the code needs to be. So we'll put that in our snippets and we'll say, for this, that's what we need to do, right? Now, we've been kind of infamous, well, not infamous, but I commonly do this wrong. I commonly make mistakes with my bit shifting logic to where I'm very paranoid about it. So the more snippets I can make, and the more snippets that I can make that I can use over and over and verify their correctness, the less headaches I'm going to have. Because making mistakes with bitwise logic is very hard to detect because C code trusts that you know what you're doing, right? So if you don't know what you're doing and you write some bit shifting code and you do it wrong, good luck hunting down the weird bugs you're going to get. Beracer means, or beracer means, or beracer means, beracer means. Okay, and so we'll say beracer, and that is going to be bit eraser, right? It's literally erasing one single bit. Erases one single bit. Okay. So B actually, let's not let that be a thing. Let's go over here and use this as a typo, because if we type it like this and then it auto-corrects and then we're not reading closely and we think the name is one thing but it's not, beracer, bit eraser. Okay, yeah, so that's in our shortcuts now. Okay. Bit eraser. Alright, so beracer is for bit eraser, right? So we're going to take that bit index and we're going to shift it over. So we're just going to take a 1. We're going to take a binary 1, right? And we're going to shift it over and then we're going to flip it, right? So the only bit that's going to be a 0 is the bit we want to erase. So we take this 1 pixel and we bitwise AND it, so 1 AND symbol with beracer. Erase bit. So we're going to erase that bit, and then we're going to say we have this new pixel. We're going to bitwise OR that with the new bit. So we're going to erase the bit, and then we're going to erase the bit, and then we're going to overwrite it. And we could just start off with like 0x0 like that. Okay. So here's our 1 pixel. We erase it, and then we OR it. So OR lets us kind of mash bits together, right? So if it's set, it's gonna go. If it's not, so this new bit here, we got to figure out what that new bit is, right? So to get that new bit, actually, I'm going to change my steps. We have one more step. Step 1. Get bit value to set. Okay, so over here we're going to say step 1. And then we'll just keep the names here, right? So get bit value to set. Step 2, extract 1 pixel. So we're going to extract this 1 pixel. This is step 2. So 2, 3, and 4. And I know we're nested too deep, but sometimes shit happens, I guess. So we're going to get the bit value to set. We're going to extract 1 pixel. And then we're going to change 1 bit. We're going to change 1 bit. So this section right here. Change 1 bit is Beracer. Here's the new bit. So this is step 3. We're going to change the 1 bit. And I feel like my numbers are still wrong here. I feel like I screwed this up. Step 1, 2, 3. No, change bit and then put pixel back, right? So put pixel back. So over here we have step 4, put pixel back. And I don't know how we want to do this. Let's just do ... right? Because it's not like a it's not a kind of like section divider like we usually write it. It's very deeply nested. So yeah, this sucks. Okay, I hate how deeply nested we are. Okay, so we got these different steps, and we can highlight them really quick and do a sanity check that all these steps are accounted for. So we got these 4 steps. So cyan, orange, yellow, and purple. Excellent. So get value of the bit to set, right? So to get that value, all we're going to do is we're going to take, first of all, U32. So this new bit is what we want. So this new bit is what we want to set. U32 new bit equals 0, I guess. 0x00. And then if, God, this is kind of ugly. Is this called PNG pixel? Is that what it's called? Are we sure that's what it's called? Yes. Okay. So also, do we have some error checking for this to make sure that PNG pixel is... Yeah, we do. Okay. Cool. So in here, we're just going to take this kind of code here, right? So this kind of thing here. We're going to use it and say, okay, the default is that it's not set, but if this is greater than 0, right? Pixel component at index plus 0, right? If that's greater than 0, then new bit equals 1, right? Okay. And oh, that's ugly. That is ugly how deeply nested we are. Oh, that's just the reality of it. Okay, so actually, let's change this up a bit. So if 0 or... Okay, let's just change this around a bit. Hold on. So if this is true, if any of these cases are true, right? So PNG picks PNG component dex +1 greater than equals 0. So if any of these channels are, what about the alpha? Alpha defaults to 255, right? So we don't care about the alpha. Do not look at alpha. Okay, so, right, red, green, blue, right? So, greater than 0, right? So we have red, we have green, we're out of room, blue. We have red, green, blue, and this, if we wanted to look at it, that would be alpha, but we do not want to look at alpha, right? So if any of these are the case, new bit equals this, right? Else, okay, and so it should be greater than or equal to 0, and it should be less than or equal to 1, right? So this new bit here. And so let's just call this, like, I don't know, make it a little trap value, this new bit here. Yes, we have written a little bit convoluted, but I just want this 1 and 0 next to each other. That's kind of nice. Okay, so this was step 1, right? Get the bit value to set, right? So we have this new bit value. Okay, then we want to extract 1 pixel, right? So we're going to take this 1 pixel, and we're going to take each one of these components, and we're going to bit pack it into a pixel. So we're going to extract it from CPU pixel. Oh, hold on. Yeah, so we want to extract a pixel on the destination that we're going to paste to, right? Okay, so this is our 1 pixel, okay? So then we're going to erase a bit. We're going to use that bit eraser within that current bit index that we want to look at, and we're going to erase that 1 bit. We're going to erase that bit, right? So the new pixel is going to be the original 1 pixel from the source. We're going to use an AND, a bitwise AND, to mask out the 1 bit that we're trying to erase. So this is our eraser mask, basically, right? So we have everything is like it was before, but we've kind of knocked out 1 bit, right? And then we're going to put that bit back. We're going to put that bit back, but we're going to replace it with the new bit, right? And so we use a bitwise OR to smash bits together, right? So now that we have this new pixel, right? So we had the 1 pixel, the original pixel, right? So old pix / 1 pix, right? So you could think of, you know, one pix could also be thought of as the old pix, right? So we got this 1 pix. We're going to replace it with this new bit. And then, finally, we have to put it back, right? So the operation that we did here, right, we have to do kind of the inverse, right? So we have to take kind of like this stuff here, and we got to do some type of inverted operation. So we know that we need to take these components. Now, we didn't actually change the alpha channel, so we don't actually have to look at the alpha channel. But for consistency, and also because the code might change in the future, we want to put everything back. So this will equal right. Let's just say value red, value green. Okay, let's just do this. I know I keep on changing my mind here. Value green, actually, well, actually, V is better because then we don't have like a BB, right? If you did B like this, then this BB looks kind of weird. So let's just do value red, value green, value blue, right? Or we could say unsigned red, unsigned green, unsigned blue, right? Maybe. And we can just say U32 unsigned red. How are we going to get that? Well, we're going to take the new pixel, right? So the new pixel, and we're going to shift the other way. So we shifted 24. We're going to shift 24 the other way. So we're going to shift it into the least significant bit position, and then after that we have to mask it. And I almost made a mistake. We need to mask it with a one and, not two ands. So I almost screwed that up royally. We're running out of room here, so we're just gonna write it like that. Red, green, blue, alpha. Okay. So 24, 16, 8, and a shift by 0. So red, green, blue, and alpha. Okay, red, green, blue, alpha, right? And these are this is shifting the individual bytes into the least significant position and then masking them out to get a value within, this should actually be a U08 right here, right? And we can tell that because we have this mask right here, right? Which is going to make sure of that, right? So this is a U32, but so this is like a 32-bit pixel, and we're going to break it into its components. And then once we've broken it into its components, we are going to place it back into the pixel array. So now I am worried, because holy crap, this is ridiculous. So an AND symbol to mask, shifting out, okay, that should be correct. Shifting the other way, 24, 16, 8, 0. 0, 1, 2, 3, bitwise OR. Like, there's plenty of possibilities for totally screwing this up, and if I do, it's going to be very hard to detect. So, you know what? Here's what we're going to do. We're not going to write any tests, but if things start to go wrong, if things start to go horribly, horribly wrong, then that is when we'll write tests. That's when we'll worry about tests, if things start to go wrong, I guess. So holy crap, there's just a lot of stuff in here. Okay, so why do we do this, right? Why do we just write all that code? And it's because this, not this thing, but the function that is calling this, we had to add these things here, right? For the 1-bit color, because we decided 1-bit color is what we want to use. And then in here, right, so instead of bit packing everything on top of I was thinking of a more elaborate pattern, but I think this makes more sense, right? So it's that exact rectangular region, but we just use a certain layer, right? Rather than doing weird transformations and trying to shuffle things together, we can just use one exact layer, and it's a 64 by 64 layer of pixels. It's a 64 by 64 plane in terms of pixels, but we're only using 1 bit out of the pixel cross-section. Okay, so now that we have that, bit back glyph assets into Taudump memory. Okay, so first of all, we're going to remove this because we're about to use this. So in Taudump, we got, oh, so many variables here. So we're just going to steal this, and we're going to paste this right here, because this is the workhorse function to do all that crazy initialization that we wanted. And let's just do this, right? So this can just be, this is the example code. This is actually exactly what we want, right? So just throw that in there, right? So bitmap data to paste into texture memory, right? Well, technically it's not the bitmap data, it's more of the supplied as a compressed PNG file, right? So yes, that is what it is, but it's compressed as a PNG file. So this is the PNG binary. Binary number of elements. Number of U32 it's the number of U32 elements, right? This right here. And actually, we're indented a little bit further than we need to be, right? Because I kind of like just... Well, no, we're not. The pixel width, right? So the pixel width is... and this is not init. This is just init. Uirects init. Let's just call it Uirects init so we know where the hell we are, right? So what I would like to do is say, you know what, this is really not boilerplate anymore, is it? Not really boilerplate, so lower encode. So you know what? It's not really boilerplate, right? The init none is kind of boilerplate, but if it's an init function and not an init none function, then it's not actually boilerplate as far as I'm concerned, right? This is not boilerplate. This is actually kind of like important code, right? So, hey, look at that. Now it's not doubly nested, and we have more room to write stuff. Oh, that's nice. Cool. So, the pixel width and pixel height. For this actually just needs to be 60... this needs to be 64 by 64. Right? So, we'll just... 64. Pix width... So, deflated? Oh, inflated, right? Deflate is getting less. Okay, yeah. So, right, so this is the pixel width and this is the pixel height of this asset here when it's inflated, right? So this is the actual PNG binary here and the number of elements in the PNG binary. Because the PNG binary is encoded as an array of uint32s. But after we deflate that, it should be 64 by 64 pixels. That's where we're assuming it is, right? Okay, so now that we have that, the Taudump, how are we doing this? Well, we already kind of decided what we wanted to do there. Now, we should have some way to formalize that, I think. Let's save this for a second. So first of all, let's close this. Let's close TauSync. We'll keep Taudump open for a second. Now, do we have a Uirects data? Yeah, we do. Okay, so in that data file, do we have anything that tells us where this stuff needs to be? And we do. We have this Uirects Taudex. So this is the index we should use for Taudex. So we'll copy this, define here, and this should be, this is Taudex. Oh, dextau. Did we screw this up? Do we have like a dextau? I bet we have a dextau in our code. Like if we do dextau, we probably have a dextau, right? We probably screwed this up somewhere. Find and file. Let's see how many times we've used a dextau in our comments. Yeah. Well, we'll just have to do that, right? Because we screwed that up. Okay, so we have these locations. Top level allocation for static glyph data, right? So it's going to be in tau 00, right? That's where we're going to use that's where Uirects is going to be stored within the Tau depot. And let's just call it, let's define this. Define AAC 2020. Do we have anything else in here that could signify where that goes? No, we don't have that configured anywhere. So we'll configure it here. We'll codify it here. Uirects. And this will be sub 00. And that location is going to be 0. Okay, define AAC 2020 Uirects sub, and that is going to be, if we look at the Tau depot for a second, right? So a subcell, we're going to go paste 0 to 5, right? So in the subcell, so we're going to open up here, but we don't need this whole cell. We only need a 64 by 64 section. These are each 32 by 32, so to get 64 by 64, we have to select 0 and 5 and create this selection region. So for that, that needs to be a 5. Now the question is, we're always going to use this for all the Uirects, but this is going to be for for a very specific fonts, right? So I'm thinking we take this thing here, right, like this. I mean, that's kind of a thing. Right, but then we can make the connection here, right? Like if we want to connect the dots, right, we can try to take this part, right? And we can say, hey, look for where that shows up, right? And if we do that and we do a find in files, we're gonna hopefully be able to connect those dots and see, oh, it's in hard-coded assets. It's in It's in dump ass, it's in Uirects, and Taudump, and we can kind of see the connection between those, right? So where to paste, so basically where to paste, 64p08g png slash, right? Where paste, let's try to make this shorter, right? So this is where to paste this, right? So where we want to paste this is, yeah, so this is just a subsection of that, so it makes it easier. But yeah, so 428 and let's just make it 429. So where to paste, right? So what do we mean by that, right? So this right here, these variables here, this one and this one, are a 0 and a 5. And so in Taudump, it's because dia subcell, we're going to use dia subcell, and we're going to go 0 and 5. We're going to select this rectangle. We're going to select this cell and this cell, and then figure out what pixels that covers when we make a selection rectangle. It's going to cover all of this, right? So we should say see dia subcell in Taudump.h, right? Right, so see dia subcell in Taudump. Did I say .h? .d, Jesus. Okay, so that is what we want to do there. And so now we have all this kind of crazy commentary. But the nice thing now is that now that we have this and we've codified it, we can get rid of this commentary here, and we can say, hey, this is the sub, right, and UI. So we're always going to paste things into this Taudex, but this specific asset, this specific asset gets pasted here, right? So this is what specifies min. So this is the min cell, and this is the max cell. Okay. So we might want to make a note of what we mean by min cell and max cell. So over here, let's just make a note of that. So min cell and max cell. We'll put them together. We'll pair them together. So max cell. Minimum cell of rectangular cell. Sorry, top left cell of cell selection rectangle, right? And then at max cell, that is the bottom right cell of cell selection rectangle. And let's actually call it of cell selection rectangle. Let's put underscores between it like that, because this is one concept, right? So this is one concept, so let's do it like that, and then let's also put it in between brackets so that it makes it a little bit more obvious. Example, Uirects.d creates a pixel selection rectangle by specifying hashtag dia var cell cells. And then what we're doing is Uirects.f calls to paste Uirects hard-coded asset into a subsection of Taudump memory. Goal. Encode font glyphs into a portion of the free space in AAC 2020 pix name, a Taudump CPU pix. I think that's what it's called. If I have that right, so here's our example, right? So this is our example. We have an example of what we're doing. And then we might want to make @vid IID. Like, when do we write this? So in 182, and the time is 4 hours, 33 minutes. Oh, 34 minutes, geez. 34 minutes and, how about 13 seconds? How about 14 seconds? Because, I don't know, it just sounds better. Yeah, so in this example, we're at video 182. This is the time. And this is just an example of what min cell and max cell are being used for. And that is a commentary somewhere. Or do we not, do we just make these kind of @min cell and then not use it? So right here, let's just make a note. @min cell, right? So this is min cell here, and then over here is @max cell, right? So this is the min cell, this is the max cell. It's used to create a selection rectangle in here, 0 to 5 in the Taudump memory. And then in Uirects.functions, here's min cell and max cell again, these same defines, right? So location and texture memory to paste to. Specifically, texture of pix name AAC 2020 pix name Taudump CPU pix, right? Okay, so now this thing, use 1BC. And bitdex. So we need to know where we're going to store this. And let's just keep on defining these variables here, right? So this is technically a where to paste, right? It's where to paste in terms of the layers, right? So Uirects, let's just take this whole thing, right? Let's take this whole thing, and this is use 1BC, and that's a 1. True. Okay. And then for this other thing, the bit index to paste into, for now we can just make it 1, right? Or 0. Yeah, bitdex. Make it 0, so it's kind of easy. We just got to look at that. Ooh, hold on. Yeah, we'll make it bit index 0, yeah. So bitdex, right? And then we can just say, bit layer. God damn it. Too many bash scripts. What is it? It's probably like 3 a.m. Yeah. Bitdex. Whatever. And so then we can just take this right here. And we can paste that in here. right? And it's kind of weird that we're saying this, but we want to keep the data separate from the function calls, right? So we don't want to be hard. We don't want to be hard coding stuff into the function calls. Speaking of hard coding things into function calls, because we don't want to hard code things into function calls, well, then guess what? We have a problem. 1, 2, 3. 1, 2, 3, 4. Ooh, crap. 1, 2, 3. 1, 2, 3, 4. Okay. Well, then this shouldn't be hard-coded either, right? This should be kind of like defined in here. And we can do that, right? We can say, so let's just keep up the same kind of convention here. So AAC 2020 Uirects, okay? And then we want a specific rectangle. So the rectangle we want to specify is this, right? And the variable we want to specify is the pix width, right? So the pix width of this should be 64, right? So what we're trying to do is we're trying to isolate the data and keep it separate from the function calls, right? So that we're trying to figure out what the heck we're doing, right? Show me your code. So, quote, show me your code and I'll have no clue what you're doing. Show me your tables and I won't need to see your code, right? So we want the data we just want to hopefully have the data well organized so that when we're trying to figure out what the code does, we don't actually want to read the code. We just want to be able to read the data and be like, oh yeah, that's what the code does, because these are the variables that I'm messing with, so obviously it has to be doing these transformations, right? So that is the expectation. So in here, right, we're going to say this, we're just going to throw this. And then we could say inflated. We can keep the inflated comment, because it's the inflated size, right? So that could be helpful. So the width and the height of that texture memory when it's inflated, right? God damn it, what the... It's my bash script. Shortcut files. Yeah, the shortcut files is pretty big, so I guess that would make sense that it would be crashing me here. Okay, yeah. So the pixel width, the pixel height, just a lot of crazy stuff, right? Because we got like 1, 2, 3, 4, 5, 6, 7, 8, 9. Now you could say, oh my god, that's crazy, because oh god, look at this function call, it's humongous. Why don't you just put it into like an object and then you can pass the object to the function? Well, what does that really accomplish? We still have to specify all these parameters, but now we've added more surface area, because now we have to create an object type that stores all these specific parameters, right? And then we still have to fill it out, so we'd still have a list exactly like this, but instead of the list going directly to the function that we want to call, we got some extra indirection where we have to put it into an object first, right? And then the code is less readable. And what I mean by what do I mean by readable code? Because like people probably don't understand what I mean by readable code. What I mean by readable code is that I should be able to print this off. I should be able to literally go take this to Kinko's, right? Kinko's, FedEx, FedEx, Kinko's. I should be able to take my code to FedEx, Kinko's. I should be able to print it off on a printer, and I should be able to read it and understand it, right? Now, if this took an object, right? If this function took an object that had all these parameters, it would not be readable, right? I would have to hover over this and look at the IntelliSense and then inspect every single element within the object using the IntelliSense. That's not readable code. That's, yeah, I'm not going to do that. Okay, so we have a serious problem here. Our remote checking connectivity. I don't know why the bash script not working would be starting to mess with my editor, but it is. So I don't know if there's some type of memory leak happening in my bash script, like git bash. Git bash not having... Okay, not git bash. Maybe... Let me show you. I'm thinking I have bad internet connection And something about Git having a bad internet connection is causing some type of resource leak. I don't know. Something weird seemed to go on with that. Whatever, let's not worry about it anymore, it's fixed. Okay, so this U32 init and tau, yeah, so so can we indent this one more time? Can we get away with that? Oh, well, we could if we got rid of this, right? If we get rid of that, we can do that, right? So we can go 1, 2, 3, 1, 2, 3, 1, 2, 3. And why do I want to do that? Because now I can say bitpack glyph assets into Taudump memory, right? So now that I want to know, now I can say, hey, what the heck are we doing? What the heck is going on here? Like, what is this Taudump subsection? Well, that means we're taking the Taudump, right, tau, and we're dumping data into it, Taudump. And where are we dumping data? We're dumping data into a subsection. So we're not dumping data into the entire 512 by 512 texture. We're dumping it into a subsection. That is what that means. Okay. So we got these Uirects. Now, is Uirects actually a thing that, ooh. Okay, so we got Taudx. Hard-coded asset should be 64 by 64 pixels. Alright, so the hard-coded asset should be 64 by 64 pixels. This is not Taudump locations. This is more, where to paste data into Taudump memory. Uirects Taudump configuration. Alright, that's kind of what that is. It's not really locations. This is. Yeah, I got you. So this specific variable here, this specific define, the tau location. Yeah, so this is the tau location. So this is hold on here. There's nothing here. Because in Taudump, so let's look at Taudump for a second. I know we have a whole bunch of variables here. Do we make one for the UI rectangle? No, we didn't, did we? Okay, so hold on. Let's go look for this for a second. Let's see if this was referenced anywhere else. I'm going to guess it's like an unfinished thought. So let's go look for it in other places really quick. Yeah, it's only in this spot. Okay. So, this right here should be set to something. Let's go look at our kind of, somewhere up here we should have kind of PAINT5D variables, right? So 10, 11, we don't want to use these. The variable max is 11. Max variable index for sequential PAINT5D variables. Fair enough. So with that, we're going to change this to 12. And then now, do we want to store this user interface rectangle in... Yeah, because I think the PAINT5D, yeah, it should be stored here. This is kind of so we're just going to take this kind of define here. And the var is going to be, I guess, Uirect, right? Uirect. Or Uirect1 maybe, something like that, in case we have more than one UI, right? We could make it 1 based. Yeah, let's just keep it 1 based. And then, yeah, because it says P5D Urec1. Oh, P5D UR1. So, oh, var UR1. Okay, I see. So this will be 12. And then this right here, and I know we have this var UR1 for Uirect1, which is kind of weird. But then in our code, let's go find VD1 here. So VD1 is right here. We're filling it out. So I feel like we didn't do this in the same... Whatever. Let's put it after VD1. Let's not worry about the exact kind of mistake here. So, Uirect, UR1, equals this, right? So, when we're looking at this, we can see this Uirect, this UR1 matches this var UR1 here, right? And that also means that after VD1 up here, so we're kind of declaring this, we just want to say const UO8 P5D UR1. Okay, so user interface. Oh, I see why I didn't do that. UI rectangle number 1. It's UI rectangle 1, right? That's what this is. P5D UR1, right? Right here. And that's over here is where we fill it out. And it's configured over here in this define right here. And then over in Uirects, right over here, this location... Ooh, hold on. I'm not sure what I wanted this to be. Well, it says Tau location, so I think it's like a... hold on. P5D Urec1, right? So, okay. don't use. So we want to see Taudump sub PAINT5D var this, right? So this is technically what we want to use, right? So I kind of see what we're doing here. So 0182, and the time is 4:53. 4:53:05. Oh, let's do 13. All right. So there is a reason for why we have what we have. I don't think we should use this. I think we should have it here, but this is what we want. Right? So use this. Let's not have multiple variables that have the same exact configuration. I think that's just going to make things confusing. I could be wrong. I mean, maybe we want this eventually, but we can reserve the right to change our mind in the future. But for now, I don't think that's a good idea. Okay. So now what? Are we ready to get this running? Well, let's look at this for a second. Uirects is in here already. Uirects is in here, so that means this is going to get called, right? However, we're using Taudump. Taudump doesn't exist yet, so that's going to create a problem because, right, that's not a thing yet. UI fragment code, that does not exist yet either, but we're not going to stub that in yet. We're going to just stub one thing at a time. So let's stub in, well, first of all, no, let's just stub it in. Let's go for the kill here. So Taudump, right? Taudump is going to be 44, and Tau, and load so Taudump means tau load exe assets, right? Or copy exe pixels. So Taudump basically means we're going to take tau and we're going to copy the executable pixels into the tau system, right? Okay, so with that said, right, we have tau sync. So let's say we have tau sync and we have tau frag, right? And Taudump needs to be adjusted, right? So we have this 44 here. So we'll take this right here, right? And we'll overlap this here. We'll paste this. And then this is now a 51, right? So this is a 51. This is a 52. This is a 53, okay? So then down here, we want to compile up to system number 53. And now we want to do a whole bunch of ridiculous amount of work to get this system stubbed in. And I don't want to do this, but we gotta. So let's hope we haven't made any stupid mistakes that are going to make it really hard to find where our code is. So yeah, we have written like way too much code. So, well, I mean, this is why we have this kind of system here, so that if we make a mistake and we do some weird thing that makes it really hard to find the mistake, we can change libchan current and compile up to a different system number until we find that offensive weird code that we may or may not have. So, with that said, let's go and find all the systems that we need to update to stub this system in. So if we go find libchan, we got to update libchan top and bottom. Okay. We also have to update the f macros. So f macros, top and bottom. And then we also have to update in the main, we have the main functions file. So this is the top level functions, right? This is the highest level of abstraction for everything. And we can see we want to look for tau sync, right? So we want to look for tau sync, right? And F macros. And F macros, this is where we're going to start to edit stuff, right? But before we do that, let's start off in order. So we're going to go libchan top to libchan bottom. Then we're going to go F macros top, and then we're going to go F macros bottom, and then we're going to go here. We're going to edit all those things in that order. So help me, because I'm going to die. This is going to kill me here. Okay. So it's not Monday anymore. Do you want to change the date? Do we want to start like change? So the day here and the time, right? We could technically, right? The day is not even encoded in the video name, right? So we could just say, hey, guess what? It's still the same integer ID of the video, but technically it's Tuesday now, right? So we could do that, right? So I don't know. Maybe, maybe not. I don't know. Could be a bad idea. Could be blah. The only problem is then the date timestamp is going to look wrong, right? Because we should probably just keep it the day we start on, because, right, I haven't saved this video yet, and if I see a Tuesday in here, then I'm going to date it as the 16th when it should actually be dated the 15th. So you know what? We're going to keep that as Monday. We're still in Monday over here. And we're on video 182. Okay. I don't want to do... I'm getting tired. I'm getting, like, ready to just stop. But, we want to get to a point where everything is compiling, right? So, 53, 53. Okay. So, now we want to look for tau sync, right? So, we're going to go Control F, wrap around tau sync. And here's tau sync, right? So, we're going to highlight tau sync. And we're going to highlight tau frag, right? So we're going to highlight it that same cyan and orange color as over here, right? So that we can keep track of what we're doing. We're going to copy tau sync, paste it, and then instead of this being tau sync, this is going to be called Taudump. All right? And the numbers have to be changed, right? So Taudump is 44, right? So 44, right? Then 45, then 46, and just kind of horrible have to do this one step at a time bullshit. 48, 49. This needs to be 50. So 50. I need to learn how to use 10 key. 52. And 53. Excellent. So now we want to scroll through here, right? And because we did token highlighting, we'll be able to find this really quickly when we see it. There we go. That's the stuff. And in here, let's just take tau sync, right? So after tau sync is where we're going to have Taudump. So we copy all these, and the difference between this block and the other block was that this is the function files, whereas previously it was the data files. So Taudump. So here's Taudump. And Taudump is system number 44 currently, or libchan 44, not, well, subsystem 44 would be correct. The editor number, not every subsystem is an editor, right? So the editor index is a totally different set of indexes, because not all subsystems are editors. Even though I'm trying to make an editor-centric library, not all code needs to edit something. It just means that the game itself is an editor, not a game with an editor. The game itself is an editor, right? So 44, 45, 46, 47, 48, 49. Okay. So we got 49, and let's change this to 50, right? So let's do it one step at a time. Maybe that'll make it easier, right? So this, there, 50. Then over here, this needs to be 51. And I think we're going up to 53, right? Excellent. 53, yeah? Yes. Okay. So we have this updated. Now there's some other stuff in here that all this other BS. I'm not really a fan of it, but let's not. You know, you think you're gonna write the perfect code base, and you're gonna be very careful and very slow about how you go about it, but inevitably, no matter what you do, you're eventually going to dig yourself into some kind of hole. That's just the reality here. Okay, so now let's go look for TauSync again. So GL constants, pix name, pix backup, GPU data, pix load, dump assets, generate tile code, polyfills, Gpuview, tau systems, TauSync. Okay, so once again, cyan over here, orange over here, so we can easily spot what we're doing. And we're going to take this block of 2 ifs and 2 end ifs, and we're going to paste it, right? Then we're going to take this code here, and we're just going to make it like a green or a purple, I forget. And now we know what code we need to replace, right? So this is going to be Taudump. Over here is going to be Taudump as well. Okay. And I'm kind of thinking, man, we could have just, all this complexity, we really could have just hard-coded our glyphs into the shader code. The problem is that makes our shader code bulkier, right? If we have to hard-code all these arrays into the shader code's payload gets a lot bigger. So I thought, you know what, let's not do that. Let's actually make an actual glyph set. And then the pro to that is that it's a lot easier to edit that data if we use the actual glyph set. Okay, so Taudump is in here, and Taudump is right here as well, just making sure that it's in all the places. So let's scroll down to the next section that lights up orange and cyan, right? So right here. So we have an if, error, and if kind of section right here. So this is what we want right here. We want to insert more code in the middle. And so there's only 2 highlighted things. So this is Taudump now. Ooh, Taudump. And this is this 43, right? So the 43s are duplicated. So we're going to cut this out, and we're going to paste over this 43. We're going to leave the last slot blank, and then we're going to overwrite it with a 53 now, right? So all the numbers have been shifted over. So Taudump is 44, excellent. The P5D OGL is system number 53. That makes sense. That looks correct. So in here, let's duplicate this line, right? So we're cleaning up after ourselves. So let's go in here, let's overwrite this, and now we want 53 systems. And this line is duplicated, so between TauSync and TauFrag, we have Taudump, right? So you can kind of see why we want to think kind of carefully about where we're going to put this in the hierarchy, because it's a lot of work to get it in there. So we want to make a good decision based on kind of a waterfall-ish design. We're doing kind of like waterfall-ish Scrum kind of code in a way, in a weird way. Okay, cool. So that's in place. So we can we can close this. And Taudump, does that have an initializer? I believe it does. It has an actual correct initial. It has an init function, not an init none, and we can verify that really quick. And we should know this because we kind of like did a lot of work here. Ooh, maybe not. Oh, we don't. Oh yeah, this is just a Taudump is just a helper for the Uirects initialization, right? Yes, that is what it is. So in Taudump, let's go look at Taudump's data for a second. So let's go look at Taudump data. Taudump.data. I'm going to guess it has nothing in here, right? Yeah. So what we're going to do is we're going to say if AAC 2020 include if def Uirects. Okay. And if this is the case, we have a problem on our hands. Oops. So, error. Taudump has helper functions for Uirects. Okay. So this is an order enforcer, right? And this is just some extra redundancy to make sure that everything is included in the correct order. So the exact order of our dependencies don't matter, but there are certain orders, there are certain relationships in here where the relative order between certain systems does matter, but the exact order of all these does not matter, right? This is just this list you're seeing is one possible solution of the dependency graph. Okay. So we might want to make a note of why this is, right? So, at vid IID, so 182, and the time is 5 minutes, 5 hours, so let's just put this as 42. Okay. And, so why is this? Why, do we have this warning? So basically, Uirects uses, Taudump, thus, Uirects should not have been included at this time. Right, so this kind of include guard, well, it's not really include guard, it's an order enforcer. It's kind of like a include guard. I'm calling it an order enforcer. But the reason that this is going to create a failure is because this include is basically saying that Uirects has been included, right? Even if it's no matter what that value is, right? So if this is defined in any way, if it's defined as 0 or if it's defined as 1, either one of those would actually be a problem. So let's kind of make that all nice. And then we'll also have to section off this stuff over here, right? So we'll say taudump.d data section. We'll just call it data section. And in here, there is no data for this, right? So what do we want to do here? Well, we got to either comment it out and put it in a multi-line comment. Let's just do this. Okay, no data only functions for Taudump, right? So that's fine. If that's how we want to roll, that's how we'll roll. Okay, so this, we might want to change this a bit. Most of the times when I'm doing compiler conditional compilation, I want to write it like, I want to put these little pounds, make these little pound lines, if you will, to kind of see that a little bit better. Okay, so that looks good to me. We got this little order enforcer that's going to help us out. Taudump, okay. Taudump.f, and when we were in here, okay, yeah, so we just need some boilerplate. There's no boilerplate functions in here, is there? Nope, no boilerplate. Okay, so we gotta paste the boilerplate into here, right? So we have to paste AAC 2020 boilerplate. And NSSBP paste. So NSSBP paste. And we create kind of a boilerplate section. And it is going to be a init none function because it is just a whole bunch of helper functions. So there's no actual data initialization that needs to be done for this. And in here, we're just going to name things correctly. So for this, it's going to be Taudump, right? So Taudump. The halting function is a private function, right? So we're going to change all the private things first, or all the lowercase things first. This is uppercase. So this is a public initializer. We can always make a private initializer if we need it. But in terms of boilerplate, we don't want to worry about that. Okay, so now that we have this boilerplate in here, the next thing is we want to go into the side. I forgot about this. I always forget about something. In the lib, we have the silence system, right? So the silence.d, if we look at the silence data, Taudump. Now, where was that relatively, right? So tau sync and tau frag. It's between tau sync and tau frag. So here's tau sync, here's tau frag. Let's duplicate that. Actually, let's keep our kind of consistency here, right? There we go. Just keeping the... Okay, so this is Taudump. Okay? And now that we've done that, well, this is just the struct declaration that we're inside of. We want to go down here. Hey, look at that, look at that. That's let's duplicate this line. Let's turn this thing on. And this is going to be called Taudump, right? This is Taudump. The logging is on, right? So we by default, we want, for any new system, we want to by default turn the logging on. And then once we're sick of log messages from a certain system cluttering up our console, because, you know, we wrote that system like 5 months ago, we're pretty sure it works, then we can turn the logging off. But this, for now, we've never used this system before. Logging should definitely be on. Okay. So now that that is taken care of, is there anything else we have to take care of? Oh, well, we're working on Taudump, right? And we got these, we got this boilerplate section in, right? So this is the boilerplate. So the next thing to assess is, we can close Taudump, right? We just had to edit that because we were like, I think we're missing some boilerplate stuff. In F macros, let's go look at this list here, 43 and 45. So let's go look for a number. 43, is tau sync still 43? Yes, it is. However, PAINT5D is now 52. So over here, this needs to be a 52, that needs to be a 52, okay? So that spot check is fine. The spot check kind of annoys me, but I'm like, I like the safety of the extra redundancy, and that's why I've not gotten rid of those static assert spot checks. So in the init none, if we look for, here's tau sync, here's tau frag. Taudump is still something that needs an init none function, so we're going to go tau dump. There's Taudump right there. And then we're not going to rebuild this whole list because it takes quite a while to rebuild this whole list. So rather than pragmatically generate this code, we're going to just go in here, copy paste, and then just with some surgical precision, right? With some surgical precision, we're just going to copy paste over this, right? So anywhere we see this purple, right, we're going to use the token highlighting to help make absolutely sure we don't miss anything. So it's like if you think about it, syntax highlighting, color highlighting is basically like artificial synesthesia, right? So it helps you use the fast thinking circuits of your brain to process information a little bit faster, right? So I guess that's kind of redundant, fast thinking circuits to process. Okay, so the fast thinking circuits are kind of like these emotional circuits of your brain, whereas the slow thinking circuits are the logical things, right? So like, you know, your gut reaction is usually a emotional one, and then if you stop to think about something, that is more of a logical one, right? People will say trust your gut. I disagree with that. I say if it's life or death, yeah, I guess err on the side of caution. But sometimes trusting your gut is just wrong. Sometimes your intuition is just dead wrong, right? And that's on a case-by-case basis for different people. So, for example, I did a lot of gymnastics, and I will tell you, to this day, a back tuck is very unintuitive. Like, if you do not have any formal training in how to do a back tuck, do not try one. Okay, because here's what you're going to do. Because I have seen it in nightclubs. and it's a disaster because I see it coming. And really, since I see it coming, I should probably stop them and not watch in horror. But okay, so you see somebody, and you can tell from their setup that they don't know how to do a back tuck. They've never done one before. They're a little bit drunk. And they're like, hey, I feel really confident. Let me try a back tuck, right? And you can tell they're about to do it wrong because they think they need to, like, throw their body back, right, to get that spin. And that's not where the spin comes from. The spin comes from bringing your legs up really fast. Bringing your knees up to your chest really fast is what creates the rotation, right? And by tucking into a very small ball, that's what makes you rotate fast. So that to this day, it's very unintuitive, to where, like, I have to practice it quite a lot before I can do it safely on a hard surface. And it's been a long time since I've even done that because I'm getting older and getting damaged. I don't recover from damage as easily, so I try not to do dangerous things. Okay, well, I still do dangerous things, but back tuck, because it's so unintuitive and I don't have much confidence with it, I try to stay away from it. Okay, so this is in here, and now let's keep on scrolling through. Let's go find more cyan and orange, right? And just see what else needs to be edited. And I think that's actually all that needs to be edited. So this, not guaranteed to be up to date, and I'm sick of editing this list. So I'm not going to. Okay, let's close this and look at the next thing. So this is the bottom file, and once again, we're going to find tau sync and tau frag, right? Tau sync and tau frag. They both have init none functions. We're going to duplicate this, and this one in the middle is Taudump, right? Taudump. And it has an init none function, I believe, yeah? Right? Because, yeah, we just pasted the boilerplate in there, so that's fine. We have two 43s, so we want to overlap over there, over the 43, and then we want to make this a 53, right? So we're just changing the checksums to be correct. And is that the only thing we did? Yeah, that's all we gotta do. We just gotta clean up after ourselves. That's fine. Excellent. One last thing, and then the goal will be to, I guess the goal will be just to compile and get it not to crash, right? Get it not to crash, and then get it to, we can actually, like, write some controls in the, we can write some controls in the texture memory view to assert that everything looks correct. We could also turn off the, okay, we'll worry about that when we get to it. Come on, let's get this working. So, in here, once again, tau sync and tau frag, right here. Duplicate this line. In the middle, we're making that insertion for Taudump. It has an init none function, not an init function. We have two 43s, so let's paste this over here, modify the checksum, and now the order is correct, right? So now if we go here, we can duplicate this line, tau sync, replace that with Taudump, and guess what? That has an init none function, so it's already good. However, this checksum is wrong now, right? Because this has a 52, there's two 43s here. If we've done everything completely parallel, we should be able to take this checksum here, and we should be able to paste it over here, and everything should line up perfectly. Excellent. So that is all of the editing we need to do for the main function file. So you wonder, like, what this is. Do not extract, Control F help. That's just to, these macros create some indirection, and the indirection makes it damn near impossible to find the call sites for these functions, right? The call sites for these functions you're seeing right here is right here. But the indirection that these macros create makes it very hard to follow the code, so we've kind of put a band-aid on it here. Now you'll be like, well, why the heck would you add this indirection if you know it's going to create a problem? Well, I wanted a nice streamlined list of like one initialization call for all the systems to create like this roll call thing. And in order to make that happen in a very sleek kind of way, where we could kind of look over it very quickly and see how everything fits together, have that high-level overview, well, we have to hide a lot of this conditional compilation code, right? So look at all this conditional compilation code, right? If the hex dumper is included, then the init none function actually is the init none function, right? If the hex dumper is not included, then the init function resolves to nothing, right? So this macro has a discarded argument, and there's nothing over on this right side here, so it just erases that line of code, which is pretty awesome, I think. But yeah, like all this bloat, like look at all this bloat, like look at all this bloat. So this bloat obviously does not fit on a single screen here. Look at all this, look at all that, all this, right? And then, but this bloat over here, while it's large, does fit on a single screen. Okay, that's a kind of a lie, because we start at 19 here. So this is all the initialization code after the window exists, whereas when we scroll up here, this is all of the initialization code before the window exists. And why is that? That's just, I would like it all to be in one consistent block, but reality interfered with my perfect plans, basically, right? And this is why you can't really just say code a system and say, yeah, eventually I'm going to refactor this system for like Win32 code, but right now I'm just writing it generically, and then I'll just, you know, I used an adapter pattern, I'll just be able to refactor it for Win32 code later, right? Oh, right now I'm using WebGL, it'll be really easy just to shim it into Win32 code with a little bit of refactoring. No, it won't. No, it won't. It won't be easy. It'll be hard. It'll be a pain in the ass. You'll hate yourself. So I'm seeing a thing here. Do I like this indentation? Let's not worry about that. I can see I kind of did that intent. Based on this indentation, it looks like I did that purposely, but I don't know if I like that. We don't do it over here, do we? Oh, we do that over here. We have this kind of shifted over to the right here. Whatever, it doesn't matter. Okay. So now, a moment of truth. Does this explode on us? Well, I guess it's not going to explode, but, you know, you get the idea. So, what's the worst case scenario? What's the worst that can happen? Well, the worst that can happen is we introduce some type of weird syntax error into our code that we cannot find, and we have no clue where it's coming from, and we have to bug hunt forever. That's the worst case scenario. Macro names must be identifiers. Oh, okay. So I know what this mistake is already. So in our include guard, in Taudump's order enforcer, we can't if we want to do it like that, we can go if not. We can go, if we really want to keep the parentheses, we can go if not defined, which actually reads really nice, so that should fix it. Fix that one problem. Now, there could be other problems. I'm sure there's other, I'm like absolutely sure there's other problems, just because I know my ability to screw things up. So let's look at this. Oh, hold on. Not have been included at this time. Not included. So we're getting this error here. What the commentary obviously says. Yeah, so we don't know what we're doing. That's what's going on here. Okay, so at least we know that this error does actually show up if we have some problems. So that's cool. I mean, what else do we have in here? Error, comment within comment, and taudump.f. So let's go close this. Let's go look in taudump.f. Oh, this thing. So what we're going to do is we do this kind of comment style so that we can... Ooh, I see. Well, we just can't do that. Yeah, we just can't do that. Like, we're going to have to just write it like that. We're going to have to get rid of that. So the reason for that comment that was right there was because lax, right? Lax comma, lax comma, lax comma, lax comma, lax comma, lax comma, no lax comma, right? So that was there specifically so that I can see that. But it's not going to let me put this into the comments if this is all a comment area, right? Because then we have a comment within a comment. So we're just going to have to bite the bullet on that and just not, yeah. Okay, so dex. Oh, well, that's obviously wrong. There's no such thing as dex anywhere. That's such a problem. Part of me wants to turn that into a macro so that if I try to ever use this again, I'm going to be like, oh yeah, that's not a thing, but maybe I shouldn't. That's just going to be extra work. And it's obvious. It's obvious. There's no such thing as a dex. It's in taudump.f. So let's look for dex and try to figure out what that's supposed to be. It hopefully should be kind of obvious. So dex is right here on this line. And if we look at the signature, we have dex eddy. So it's probably dex eddy. If dex eddy is less than 0, yeah, so the editor dex can be 0 for the Gpuview. So yeah. Also, while we're here, we can change this later. But for now, we're going to assume we only have 9 editors, right? Because we have the 0 through 9 keys that are going to be bound to that. When we get to 9 editors, and this fails us, well, we should just congratulate ourselves because we have over 9 editors, and we've been working on the first... We're still on the... Well, we have 2 different editors, right? We have the Gpuview, which isn't really an editor, but it gets an editor index anyways of 0. And then editor number 1, which is the first real actual editor, is PAINT5D, right? And we're still not done with that editor. And we're on our 182nd video. So once we get up to 9 editors, once we get up to 10 editors, and this actually gives us a crash, it'll be a celebration, right? So for now, we know that it needs to be between 0 or 9. Otherwise, if he has some like ridiculously high number, then that is a problem. Okay, so let's make sure that's saved. Let's give it a let's open this up in a permanent console window so that we can just kind of like /AAC 2020. So we can just run the build script and just get it working, right? Also, should I like what's the most useful thing here? Do I want to actually say heavymetalcookies@gmail.com, or do I actually want this to say, or do I really actually, or should I actually say that I want my Twitch? I do have the Twitch up in the right, like over here. Can we see this? Oh no, we can't. Wait, over here, yeah. So here's Kanji Coder right here. It's not as visible, right? My email address is more visible than my Twitch. Well, what's more important to me? People finding my obscure videos on YouTube that don't get any hits? Or is that more important to me, or is it more important that people who are already watching my videos can get a hold of me? I think this is more important because let's say 10 years pass and I stop streaming. Somebody sees my videos, thinks they're awesome, but they have no way to get a hold of me, right? Well, here's a way, because it's in my videos, right? Yeah, whatever. Let's not worry too much about that. Okay. Discarded qualifiers. Oh boy, oh no. Okay. 151. So CPU picks. Oh. This is the wrong thing. Pix name. So this is a pattern breaker, but we're out of room. This is Taudump CPU Pix. That was the actual pixel name, right? Pixel name Taudump is literally the character string encoded in my source code. That literally it's literally a character array that says Taudump, right? So the variable that's this is literally a character array that says Taudump, and it's just I believe it helps me identify. It helps with linkage to my shader code, if I remember correctly, to link to the texture memory, something like that. Setting up the textures, I believe, is what it's used for. Or it might just be used to make things official in the source code. I don't remember. Anyway, so that means that this CPU pixel is... Well, it's nice that I made that a const char, because I would never have been able to... that would have had me tearing my hair out for quite a while. So PAINT5D, right? So we got Taudump, and we got PAINT5D. The Taudump is kind of a disaster because the editor associated with Taudump is kind of like Gpuview. It's ugly. We try to keep a one-to-one relationship between texture memory and editors, but the Taudump Gpuview thing is not one of those, because Taudump's memory is shared among all of the editors, right? And Gpuview is not actually Taudump memory. It's an editor that can view the memory for all the different editors. It's ugly. It's ugly. Oh well. You're gonna have some ugly parts to your code. That's fine. Okay. Let's give it a shot. Let's give that another shot. See if that cleans it up, or if we have some other stuff. We have a lot of code we wrote. It's like, why the heck do we have so much code? It's like, what did we do? We just wrote a whole bunch of code to cut and paste pixels. That's all we did, and holy crap, it's complicated. Yeah, this expression is always true. 257. Yeah. Sure. Let's just comment it out like that, right? So it's unsigned. It should never be, it should always be unsigned value, because this is a bit value, right? So, sure. We'll just remove that, but we'll keep it here because it just makes more sense in this context. We're like, oh, it's a 0 or a 1, of course, because it's a bit, right? So I still want to keep that there for a reminder. Undeclared 356. Okay, so let's look at 356. So this sucks, but at least it's low-hanging fruit is nice though, because it's not low-hanging fruit is like, oh well, yeah, oh god, well you have mistakes, but at least they're like easy to figure out. So this was a cut and paste job, if I remember correctly, because we can see rec x0 y0. We can see this connection here, and guarantee that the mistake here is just that when we cut and pasted the code, that's what we want. Instead of x's, we'll do x remainder. X is the remainder, y times stride. That's kind of ugly. But then we were, whatever. So the x is the remainder. So that's why you have multiplied by 1. But then the y needs to be multiplied by the stride. And then we have to multiply by 4 to get the offset in bytes to the, right, times 4 to get the component index. So offset in bytes to first byte, right? It's this OIB TFB, ridiculous variable name. And we use it right over here. It's refactored from some other code. And I already see a problem here. There we go. Remove that semicolon because we're inside of a function call. Do we do anything else stupid in here, or is that the only stupid thing we need to clean up? I think that's the only stupid thing we need to clean up. Okay, cool. So let's keep on going here, and let's just see what we got here. Oh, and also, I would like to kind of check my Imgur and see if I got any kind of feedback on the 392. So we're making progress. We're getting along here. 392. So this is a function, right? So this is the closing scope of a function. And because it's the closing scope of this GL text sub-image thing, because it is, yeah. So that right there is this right here, right? So we might want to write that like that. So because it's a very big function, so we might want to just do this, right? So we can see here's the top, here's the top, here's the bottom. Here is where it's called. So here's the top of the function, here's the bottom of the function, here's the call site. Top of the function, bottom of the function, call site, right? That could be useful. Now this thing here, same deal. It's pretty long as well. We probably did the double semicolon BS again as well. Oh, no, we didn't. We actually did it correctly. So once again, this is the bottom of this function, so maybe we want to reference that, right? I don't always do that, but sometimes I think it's useful. Okay. So let's give it another shot and see if we can get through this alive, because I want some food. I think I want to, like, keep on coding, but, like, if I put some ribs in now, 6, 7, 8, 2 hours from now, they'll probably be cooked enough. Yeah, I might want to take a step here to tau width undeclared. Okay, we'll fix that. Tau width should be 512. I know that already. Ooh, no, it should be 4, because it's the width in terms of cells. Okay, yeah. So we're going to take a break. We're going to take a break so we can just prepare some food. And we can reheat our coffee as well. Oh, actually, before we do that, though, I want to check out imgur.com and see if anybody likes the gallery I posted, or if they just hate it. And I don't know how to find the gallery profile, because I don't know how to use Imgur. Images. Oh, it's, no. Images. There's where we make a post. I actually save this in my shortcuts, so like if I can't find it, I'll find it in my shortcuts. I just want to check this out really quick. New post, add images. Oh, right here, gallery profile. I think it's gallery profile is 198 points, neutral. So I'm more in the positive than in the negative. Ooh, downvotes. So I guess people don't like that. Because it's not memey. It's really because, like, right, the culture of Imgur seems to be kind of meme stuff. Imgur seems like it's meme stuff. Pinterest is like crafts. And I guess I'm on the wrong platform, right? So, because we can tell this is memey stuff because, well, this has more upvotes than downvotes, even though I'm selling memes, right? So this one was kind of volatile. This says upvote down. Oh, so the one upvote is an automatic upvote. But this is, 14, right? So this has upvotes, right? So this has upvotes, right? It's just meme trash, right? This is actually cool, interesting to look at, but upvote and upvotes, downvotes equal. Downvotes probably because it's like it's just like advertising to people, so they don't like it. This is actually interesting. Completely neutral. A lot of people saw it, but no upvotes, no downvotes. So we'll assume that no one has strong feelings about this, right? So we could think of it like that. Like when we're looking at this, we could think that when we see this, no strong feelings, right? If we see this, no strong feelings, that's kind of how we'll assume it. Some of this stuff is, right? Slightly positive, right? We could more downvotes. So it's like, oh man, the tech I'm working on gets a whole bunch of downvotes. So it's like, Jesus Christ, 2K. So it has 2K and don't know why. Oh, you know why it has 2K? It's because it's on my website. It's probably, that's why. So yeah, I mean, I try not to be depressed. It's more like, this is just knowing what people think, right? Know what people think and try to use that to your advantage, right? So, Imgur, but for game design. So maybe I'm missing something. Maybe there's already a platform. Maybe Reddit is for our game dev on Imgur. I don't know how that works. I guess DeviantArt, maybe? Maybe DeviantArt is where we want to put our stuff. I don't know. GIF gallery sites. Find the perfect GIF. Let's try to figure out where to put our GIFs. Giphy. We might want to try all these things, right? We might want to try all these, right? So, every single kind of like, if you look at, I don't know why Pinterest isn't on here, but yeah, every kind of site has different, one more popular ways of driving clicks to sites is by using video GIFs and emails. Can boost open rates by 6%, can increase click rates by 42%, drove 103% increase in conversions, grew revenue by 109%. Yeah, so I mean, having GIFs is a good thing, right? I'm actually getting hits on, from using, right, so Imgur and Tenor look like it's the same kind of thing. But does anyone have like a culture that's more... Okay, let's face it. There's no such thing as a mainstream nerd culture, is there? There's... let me rephrase that. I don't think there's a mainstream popular STEM culture. Science, technology... What is it? Science, technology, engineering, and mathematics? Yeah. Right, it's all going to be lowest common denominator stuff. So yeah, so let's face it, anywhere I post, and maybe my engine stuff just isn't interesting, right? Maybe, but maybe that's a sign, right? That we want to see what the public opinion is. So anyways, we're going to make a note of this, right? So the GIF sites that we want to use, we want to like start using all these GIF sites. So GIF sites to use. And also, let's make a note of the other GIF sites we can use. So let's do GIF sites. Giphy, we got Reddit, we got Imgur, we got Tumblr, Image Flip. I think this is stolen from the same article. Yeah. More items. Let's see if there's more. No, it's going to be the same goddamn list. Let's not. Okay. Okay, let's forget about this. Oh, who's messaging? We don't know what's gonna happen here. Never had a message. It's probably an advertisement. No one personally messaging me, right? Yeah, Pinterest. Yeah, this thing right here. I'm like, oh, I got a message from somebody. Oh no, it's just Pinterest. Thank you for sent a pin. Okay. Interesting that there's an inbox. Okay. I guess that's helpful. Okay, anyways. Let's close that. Let's actually start some food. Well, hold on. Let's fix whatever here is to get ourselves in the train of thought here. So Taudump on 457 and probably Taudump.f. So 457. If we look at that, Taudump. So we got Taudump, we got subwid, and is it only in here? Okay, let's just make these macros local to this section, right? So this, in this step right here, we're just going to define Taudump, and that should be 4, okay? So 4 by 4 cells, right? And if you want to know why, you can check out the taudump.data, right? Subwid is also 4 by 4 cells. And once again, if you want to know why, you can check out taudump.data, right? So in taudump data, we have a nice little diagram which can explain, oh, 4 by 4 cells at the tau cell level, right? The tau width. And then at the subcell level, we also have 4 by 4 cells, right? It's only once we get down to the variable cell that we have 16 by 16 cells. So both these are 4 and 4. And so we're saying at step 1, we're just going to paste the macros here, right? So undef tau width, undef the subwid. Right, so tau width and subwid. Okay, cool. So let's keep on going now. And then what? I don't know. Let's just unknown type name IO8. So that's because we got a UO8. So in this big section, all of our like prelude macros, we probably don't have enough of them. So UO8, U32, I32. So the one we're missing, right? We have most of them except for this IO8, right? This int 08. And the thing is maybe we should be careful that we're not making a mistake here, because IO8 pointer. No, it's not. Taudump CPU pixels. Not a IO8 at all. It's a UO8, right? So yeah, before we even So that was just wrong. Let's not make that macro if it actually isn't used, because the fact that that macro did not exist in that section actually helped us catch a mistake. So yeah, I'm seeing a whole bunch of stupid mistakes, so I'm kind of scared that this is just going to blow up in my face once I get it working. CPU pix name, Taudump, CPU pixed, unused variable. Really, 495. Okay, let's go look for that. Maybe I should have did a control G there, because this is actually taking longer. 495. Okay, so CPU pix right here. This thing not being used for some reason. Oh. That's because Dex Eddie. Dex Eddy is going to identify the CPU pixels, right? Yes. Got it. I understand. Actually, we can just get rid of the semicolon, right? Because we don't need let's make that blue. I don't know. Always Taudump memory. We don't have any use for. Right now, we only use Taudump memory, but it is, no, that is just spam. It is, so if we look for the Dex Eddy in here, sure. Okay. Yeah, so this doesn't need to exist because we're using this to identify this. So the Dex Eddy is going to use Gpuview, and that's what's actually going to locate this Taudump memory. So yeah. Okay, one more. Okay, we're gonna try to run this, and then we're gonna go do like a 5-minute break. We're gonna do a 5-minute break, and we're gonna make some food, so that when we're done coding, we have something to eat, I guess. Unknown type name U32 is still in Uirects.f, so we can close this, I guess. And let's go open up Uirects.f. And it's on line 41, so line 41 right here. Uirects init and a whole bunch of code. We need a U32, and then everything else we don't need because it's literally a whole bunch of defines that we've used to configure this. So that's cool, I guess. Define, so let's say define U32. Okay, and then down here we can just undef U32. Okay, and let's give that a run. Looks like it's gonna. So now we're wondering, is it gonna crash at runtime, right? So, that looks like runtime. Oh, maybe not runtime crashing. Maybe not runtime crashing. P for pattern. We can see the stuff. Kind of as expected, right? We didn't. So if we do the if we do 0 for the memory view, we're not going to see anything special because we're not looking at the memory that we want to look at. So you want to do like a ASDF or ABCD? What do we want to do here? Okay, so we're gonna come back to this. We're at a good break point where we can go downstairs, go upstairs really quick, and put some food in the oven. So let's do a break timer. Oh, it's 4:20. Break time, food time. Okay, interesting. Red timer. And all we're gonna do is we're gonna go upstairs and we're going to. So 6 minutes is usually okay. Well, we have 6 minutes, but usually 6 minutes is what we need. But we also are going to take food out of the freezer and get it into the oven. So 2 extra minutes probably, just to heat up coffee, put food in the oven. At 200, 250, 250. Okay. Back in time. 6 minutes. Ish. Okay, so another thing is to inspect that memory, to see if that memory looks correct. Let's just kind of hackishly do this, right? So, if we look at our Gpuview, right, Gpuview, and we look at the fragment shader, I think the fragment shader is what we'll need to look at. And somewhere in this, really? Video number 112? Wow, okay, so that was a while ago. We're at 182, yeah. Yeah, because we couldn't, Gpuview was made because the Taudump wasn't working correctly, right? So in here, we have a whole bunch of helper functions, it seems. Frag color. Okay, this is the main function. Okay, so where the heck is... Paired comment, Gpuview asserts. Okay, well, is this like in the actual same code or is it in another file? Oh god, it's in another file. Okay, so we made a note here to say that, oh, this is kind of like exists somewhere else in some other code. So let's go find this, and it should show up in 2 different files. So in the fragment shader and in the trash, gpu.frag mod, I don't see it in 2 places. Well, it is. It's in 2 places, just one of those places happens to be the fucking trash. Fine. Okay, so this assert here is probably for the very specific memory block that I wanted to look at, right? And I want to look at that. I don't want to look at that memory block anymore, so so here's what we're gonna do. We'll just make some defines. So if we're inside the 512 by 512 area, okay, sure. So let's just say, let's just define what these are. So we can see dextal looks like it's 3. Let's go open this up for a second. So in Taudump, oh, it's not dextal. That's tau 0, 1, 2, 3, 3, 3. I see. Tau cell X, right? Tau cell X is that, right? Okay. Define tau cy was 3. So first what we're going to do is we're going to edit this shader. I refactored a bit. So the subcell that we're looking at, what subcell are we looking at? Well, we have 3 and... So we have 3 and 3 here. And then over here we have 1 on the X, 0 on the Y. 1 on the X, 0 on the Y is this thing here, PAINT5D, right? That we're looking at PAINT5D memory. So that is 1 on the X, 0 on the Y. Okay. And that's fine. And then the last thing we want to look at is, no, we only care about those two things. So we're going to look at the exact, we're going to look at the whole cell. So sure, tau cell, subcell, X and Y. Okay, and then outside of this block, so when we find the end of this else, this is where we'll kind of clear up these defines. So we'll undef them down here. Okay. And do we want to check some? Well, we're about to write a checksum because that's what we're doing. So that is what that habit is about. Okay. So and then over here, do we want to check some here as well? I don't know. I guess maybe. I guess we could kind of do like something like Okay. And we're just gonna compile this. It should still run. There shouldn't be any mistakes. Like, I mean, the shader code should still compile without any hitches, but it should just we just want to edit a little bit of code, make sure it runs. Edit a little bit of code, make sure it runs. Right. So if we look at this, right, it's still there. It still looks fine. And now we want to I kind of regret making these. We don't have to be efficient here. We don't need efficiency here. So let's not make these. Let's not make those defines. I take it back. Okay. It's going to be like a configuration in the shader. And it's going to be an int32 just to keep the math simple, because these are already ints, judging by the way we did this math. And, right, this is going to be tau and sub, right? So can we just do this to TLCMD? Does that actually work? Probably not, right? Ooh, no, it does not. Okay, so we just got to say tau. And this is sub. And this is, we got the CX and CY. Cell X and cell Y. And it's no longer a macro, so it equals these values. And, if, call it mem macro. And right, if mem macro so this is the macro part. So if this equals the so if memmac equals this, right? This will just set this to we'll keep these uninitialized here. And then we're going to hashtag, we're still going to define a macro, but it's going to be called macro PAINT5D memory. We'll just give it a 1, and then int32 memmac equals 1, right? So the memory macro, what memory do we want to look at? Well, if the memory is the PAINT5D memory, then this is kind of what we want to look at, right? Now, let's take that to the bank, and here's where we made all these defines. Let's just undefine this right here. So undef space, we just have this one macro now. So PAINT5D memory, well, we're going to have more. Define macro Uirects memory 2. Okay. And then we'll change this, right? And then this macro thing, this kind of thing here, right? The assert we have here, right? We have this nice little assert stuff going on here. We can make this an if and say, you know, if this is the case, right? So if this is the case, these are the asserts we want, right? Now for this, 1, 2, 3, 4. Okay, cool. So that's just within the scope of what we want here. Also, let's kind of like just do that. So I don't know, just want want to imply the region of code a little bit better. Okay. So if the memory macro is the PAINT5D memory, these are the exact values we're expecting for those bounds after this computation. If it's not, then we're not going to do those asserts. Here is this memory region. Else, you know, if macro Uirects memory equals memmac, then we do something else. And it needs to be one of those. But let's not get ahead of ourselves just yet. Okay, let's just make sure that that still compiles, right? We'll make sure that still compiles, and if that compiles, then we'll give it some more blah. Error expected before tau, so 272, so we obviously introduced some type of syntax error. I'm gonna guess it's probably with like a multi-line comment character that stayed open, because that's what I was just messing with earlier. No, maybe not with that. You think it's simple, you think it's trivial, you think it's just, oh, it just adds a few lines of code and what could go wrong, and then it's like, well, something went wrong. Unexpected error, so we're missing a semicolon? Are we missing a semicolon? Yes, we are. We're missing semicolons. That's what we're missing, right? Because we turned the macros into variable declarations, and that also means that we have to put semicolons after them, otherwise that doesn't work out, right? So we can just initialize these all to 0, I guess, because why not? So that's not complete garbage if we forget to initialize it. Okay. So now let's give it a shot. So the nice thing is the C99 compiler caught an error in our GLSL code because of the way we wrote it. Set but not used. Sub CX. Yes, it is set. It's not used because okay, let's just fix this, right? So tau CX is our 3, right? So tau CX, the cell X, the tau cell is the 3, right? The tau CY is also a 3, but it's the Y. Oh, this is also tau CY, right? So this is also tau CX. And then the sub is this, right? So the sub is 1 here and 0 there. So sub CX and sub CY is the 0. So here's those zeros. Okay. And if we do that, we might as well kind of like kind of like fix this up a little bit, make it a little bit nicer. Okay, so let's give that a shot, right? We just want the original behavior of the shader code to... We want the original functionality. We want the original functionality back, right? So what we're hoping is not to get a syntax error right now. Okay, cool. It didn't blow up on us. Excellent. We see the same stuff we saw before. That was the plan. So now the case that we want to add into this shader code, right? And this is kind of rudimentary, kind of hackish, but it's just for debugging, so it doesn't need to be awesome. This thing right here, what does this need to be? Well, if we look in Tau Depot for a second, we see, okay, I already know that I put the UI rectangle here, and then I put stuff here, right? So to get this working, first of all, let's copy-paste this. And then the cell X, cell Y is going to be 0 and 0. And then we also want to look at, for the subcell, we want to look at 0, 1, 4, and 5. So let's just look at it one cell at a time, right? So just make everything 0. And then for the memory macro, right, instead of 1, it's going to be 2 for the Uirects. So it's going to end up here, right, Uirects memory. And if we run that, I have no clue what we're going to see. I don't think we're going to see anything interesting because we just overrode the least significant bit with data, right? So because of that, we're not really going to see anything, right? Or at least I don't think we are. Yeah, I don't think we would see anything. Right? It doesn't. Now, that looks suspiciously the same as before. But like I said, we only manipulated the least significant bit, so let's make sure that this shader is being purged in our build script. So is it being purged in our build script? Let's open this with Notepad++. And if we look at the steps here, so we build the system executable, generate hard-coded assets, delete old shaders. So deleting old shaders, in fact, Gpuview is deleted. Okay, so it is cleaned up. So we're good there. So what I would recommend to try is in the Uirects data. Right now we're saying, oh, we're going to use 1-bit color, right? Set that to false so that we can just paste the entire bitmap, right? And just see if that works. Because right now, I don't really care about... we don't have any other bitmaps that are being used on any of the other layers of the pixel, right? I say layers of the pixel because I'm saying that if we do 1-bit color, we can treat a pixel as having 32 different layers. So now if we do that, we should see some type of weird kind of like glyphs that have probably a weird tint effect applied to them, but we should see something like that. Yeah, there we go. So 0, 1, 2, 3, 8, 9, A, B, G, H, I, J. Right, so we're seeing those glyphs, right? So we're seeing the first 4 glyphs, and let's make sure that that actually looks correct. So 0 through 3, is that half? Is that half of them? So if we look in our lib and we look in our assets, and we look at our Uirects data right here, and we zoom in here. Oops, no, zoom in. Enhance. I thought the mouse wheel was supposed to zoom in, but it's not, and that's annoying me. Okay, but yeah, we can see 0, 1, 2, 3, and then 4, 5, 6. So let's confirm that. Now, let's confirm that everywhere else. So why don't we just take the time to visually verify everything? Because you never know. You might think, oh, it works, and then you try to do something different, and then it doesn't work. So let's try to go over to this cell here. So 1 on the X and 0 on the Y for the subcell, like that. And if we give that a run, do we see the 4, 5, 6, 7 numbers, right? So do we see those, or do we not see them? And it would be nice if we had some like controls in here, but oh, we'd have to probably refactor where we put this if we really want some controls for this editor, because I don't think the keyboard, I don't think we have the keyboard bindings for what we want to do here, and that may have been a mistake, because we were thinking Gpuview would be like this rudimentary. So there we go. Yeah, we have this same stuff, right? 4, 5, 6, 7. Okay, now if we want to go 0 and 1, right? So we want to look at that lower left corner and see what that looks like. We should see some of our notes we wrote in gray. They might not display in gray because of the way we're tinting the pixels, but we should be able to see those. Okay, so let's take a look. Oh, yep, there's the little note there. There's our little note. Okay, so one more thing. The bottom right-hand corner. And with this, we can kind of confirm that things are being pasted where we think they're being pasted, right? Now that doesn't mean everything's correct, right? Because this is the full 32 bits being pasted in this location. But if we change that to, so let's put this back at 0, 0. Or actually 1, 0. I like 1, 0 because 0, 0 just bothers me because it's exactly the same as this. So if we look at this, we're going to see like 4, 5, and 6. So here's 4, 5, and 6. Okay, excellent. So what we're going to do now is we're going to go into the configuration for this. Oh, hold on. Oh, no, it's UI frags. So in here, use 1-bit color, right? Well, if you use 1-bit color, we set that to true, we're not going to see much of anything useful, I don't think. I could be wrong. I don't think I'm wrong, though. Now, if we use bit number 31, the most significant bit, we'll probably see something, I think. Oh, well, it depends. We'll try a few things. We'll try. So yeah, we just see this kind of nonsense now. This is kind of disconcerting. Well, no, because right, it doesn't wipe out the old bits, right? It only replaces that 1 bit that we care about. Yeah, that's right. I forgot that. So so with that, let's replace, instead of replacing the least significant bit to create this 1-bit color image of these glyphs, if we replace bit 31, then we might see something. Now I don't know, but there should be some bit value that we can replace that will actually see remnants of the glyph. Now if we go through every single thing here, bad boolean. Oh, I screwed up here. I guess that was actually nice because, yeah, so this is here. This was the thing that needs to be 31. So I guess it's good that I had that error check in my code because guess what? It saved me from making a stupid mistake. Okay. So I don't know if this most significant bit will yield anything, but I'm hoping. Huh. No? Okay, well, first of all, if we want to edit the most significant bit and have something decent show up, let's go edit this for a second. Open with paint.net, right? So we're trying to edit the most significant bit and turn it on. Oh, hold on. That doesn't make any sense because we already have this here, don't we? Would it not? Okay, here's what we're gonna do. This 4, we're gonna make it white because if there's any mistakes in, if the most significant bit is, I don't know, man. Okay, let's just mess with it, right? Let's Okay, here's what we'll do. We'll stripe it with white, and then we'll do like a red. We may want to make it absolute red, right? So, any of this kind of BS weird colors that they use, right? So, I don't know why Paint.net is like, huh, you know what? We're gonna give you things that aren't pure RGB primaries. We're gonna like slightly tint these. Not a fan. Red, green, and blue. So once again, it's like, why? Why are you putting this random 38 in here? Like, can't you just give me these basic defaults? It's like, okay, so red, green, blue, and then we could use like a perfect cyan, maybe. Okay. And we already have a cyan there, so that's, I guess, okay. Okay, yeah. So we're just going to stripe it like this, because maybe we will see something. Maybe we won't. Also, you know what we'll do? Let's also... we can worry about this 4 glyph later and what it actually needs to look like. But let's put some white pixels right here. And a white pixel... 2 white pixels here. No, white pixel in this corner, white pixel in that corner, right? So just so that we can maybe... I don't know. Maybe that's not what we want to do. Is this actually black? Are these things actually black? Or are they some stupid tint because... Okay, yeah, these are actually black. Okay, cool. So let's save that. Let's save that. Let's save that like that, because that could... give us some better results. And then, if this doesn't work, what we'll do is we'll make these completely transparent. I don't know. We'll figure it out. Okay, so let's just give that a run, right? It'll change the hex dump. That will change the hex dump that gets dumped into the executable, which is fine. Okay, so now let's look at this. Anything? Yeah, I don't see much. So the one thing we might want to do is just turn this tinting off, right? So maybe this tinting is just looking at the bits in a very weird way because we used it to kind of debug different stuff. So let's go look at where that's happening. Somewhere in this code, we're doing some weird tinting stuff. So we can see the most significant bit that we were trying to look at is just getting multiply with 0. Yeah, so of course we're not going to see anything. So if 1 equals 1, do this stuff, so that's never going to happen. Oh no, if 1 equals 1 and then all this stuff. Hold on. What the hell are we looking at? I have no clue what this means. I think it's like the inbounds, out of bounds code, but it's like I can't even tell by looking at it though. And why is this all text.w? Isn't that alpha? It is. Texture.xyzw RGB. If it equals... If R and G and B equals 0, and W specifically equals the maxed out value. Okay, I see what's going on here. Or if W explicitly equals this. Okay, so I see. This is special tinting. Okay, so here's what we're going to do. I understand what this is. If macro use debug tinting less than or equal to 0. Okay. And if. Okay. If macro use debug tinting greater than or equal to 1. Okay, and then down here we gotta find an end if. So this is all debug tinting stuff, right? That's what this is. So end if. Okay, then we're gonna undef it right after, right? So right here in the endif, we're just gonna say undef, right? Because we don't want this. Also, this doesn't just compile as GLSL code, right? It compiles as C99 code. So if we don't undef this, it will leak into our other files, and it's a pretty unique name, so probably never collide, but there's always the possibility. Okay, so debug tinting is turned off. And so we want to say, we don't want any of these special cases. So the last case right here, just use as is, right? So okay. So we're going to turn off the debug tinting. so that we can get an accurate idea of what we're actually looking at, right? Okay. So now everything is probably going to be mostly black. Except if we successfully have set the most significant bits. I changed this. The alpha is just going to be the alpha is just going to be a problem for us, right? So instead of using this, we're going to do 255. So that's a UVec 4. We're going to make it this so we need a 255 value that is actually going to be unsigned. So UFF. Uint 0xFF. Yeah, so we can use a UFF for that. So down here, this needs to be, if we want this to work without crashing, it needs to be UFF, right? So we don't want to look at the alpha, we don't want to render the alpha channel correctly, because if we do that, everything will be completely black all the time. So at vid IID 0182, and the time is 6 hours 40 minutes, and let's say 23 seconds to keep with the conspiracies here. Show pixels as they actually are, except alpha, because if alpha is 0 for everything, so yeah, we're gonna just show everything exactly as it is except for the alpha, because if the alpha channel is black, everything will just show up as black and we won't know what the heck we're looking at. So the XYZ, aka the RGB, so red equals X, green equals Y, blue equals Z, and then once we run out of letters, W. Alpha is W. Okay. Give it a shot? Yeah, let's give it a shot. So the first thing we want to do is we just want to hope that we can compile. We know it's probably going to compile, but the next step after that is, will the shader compile at runtime without a syntax error? And if that happens, do we have anything that we can look at and make sense of? So this is completely black. So yeah, that's completely black. Well, if we look at this, we did UFF, right? So we maxed that out. So it's not a problem with the alpha channel. It just means the R, G, and B are all 0 for everything, right? And if we look at this, well, we set for the bit index, we set 31. And 31 would be the most significant bit of the red channel. Red, green, blue. So that tells me that the problem is in the bit packed version. Like if we set this back to 0, right, for not using 1-bit color, and we try to do this, we should see the glyphs. We should actually see the glyphs if we do this. Now, if we don't see the glyphs here, we already had confirmation of those glyphs, so if we don't see the glyphs here, it just means that our shader code, we just introduced bugs into our shader code, yeah. So there's that crazy 4. Then here's this 5, 6, 7, right? And so the white, we have the white here because we're saying, you know, if any one of those channels is non-zero, then we want to bit pack something in there, and that's not what's happening, right? So in our code somewhere, we gotta figure out where we're doing that. And I forget, so here's what we're gonna do. We're just gonna look for use 1-bit color thing, right? And I forget if it's in here or not, but oh, it is in here. And that's being called to Uirects init. Oh, no, this is no. Oh, Taudump, my bad. So let's go open up Taudump functions. And let's search for that exact same token, which should yield us some type of helpful stuff. We can, and look, we found it, right? So if zero is this, if we're using full 32-bit color, then everything's all right? Because this is pretty straightforward. But then the problem comes when we do this, and then it's like, oh god, well, if we use 1-bit color, holy crap, look at all this crazy bit shifting logic, and we know we're really good. We know we're really good at getting this completely wrong. So the question really is, I think, the question is not, are we doing something wrong in this section? As far as I'm concerned, the question is not, it is not, are we doing something wrong in this section right here, between this scope? The question is, what are we doing wrong? I'm absolutely certain we're doing something wrong. Oh, no. Okay, so if 0, or this is greater than 0, or that's greater than 0, or that's greater than 0, don't look at alpha. Could that be a problem? No, because we're not even looking at alpha in our... we don't even have an alpha channel in our original asset, so that's why we're not looking at that. And we obviously have non-zero RGB values. So this component index, we see the component index here, 0, 1, 2, and 3, right? So greater than 0. The new bit equals 1, otherwise the new bit equals 0. So I think this looks good. I think this is okay. Let's not highlight it orange. Let's highlight it kind of like a oops. I think 4 is green. It's an ugly green. Nope. I guess 5 is green. God, I can hardly reach that. Okay, so we're thinking, you know what? This new bit thing here, U32 new bit, I think that's okay. I think that is okay. I think that's perfectly all right. So now this 1 pixel, we have this right here, and we're going to smash it together, right? So bitwise OR is used to smash things together. So 0 or 1 yields a 1, right? So we can start off blank. So this thing here isn't going to make everything get erased, right? This would if we're using ANDs, but we're using OR, so we're using the correct operator here. Okay, good. So now the next thing is, what are we doing here? Extract 1 pixel. Okay, so we're extracting 1 pixel. Excellent. So we're taking this and we're shifting it over. We're shifting it over 24 pixels, right? So one mistake could be that the operator precedence, maybe bitwise OR comes before the shift, right? We could be doing something really stupid like that. So let's look at operator precedence for a second. C99 bitwise operator precedence. So we look at the operator precedence. Does the left shift come before the OR not? Okay, so left and right shift have higher precedence than OR. Therefore, this should be completely okay. Oh, hold on. We shifted over, but we never masked it. Yeah. We never masked it. Okay, yeah. So CPU comdex is CD, huh? So in here, we can just use that macro, right? Where's this macro undefined? So it's in this section right here. Okay, cool. And then the CD used anywhere here? Oh, use it right here. Okay, yeah. So what we can do here is we can say component index, comdex, and after we shift it over, it absolutely needs to be masked. So and 0xff. It absolutely needs a bit mask. Okay, so we caught one mistake, I'm certain of, right? Because we shifted over. If we shift it over, right, we're just going to get things overlapping each other. Right? Well, hold on here. No. We don't need that. No. We don't need a mask. Hold on. So the CPU pixels is already exactly 1 byte. So if we shift it into position, when we left shift, it's going to get 0 filled. So that it's not correct at all. We're wrong about this. Yeah, we don't actually need a mask for this. I was thinking we need a mask for this, but no, we don't need a mask. So I thought I was looking at the problem. Well, now we've solved the... Well, I guess we got more parentheses, though, in case we are totally wrong about the operator precedence. But yeah, that's not the mistake. This 1 pixel, I'm kind of convinced this is... I'm kind of convinced that this whole section as well is correct. So I'm going to give that a green. I'm going to give that green. We're going to look over some more stuff. Okay, so we got this bit eraser nonsense, right? We take this 1 and we shift it over by the bit index. So if the bit index is 1... okay, yeah. So we've shifted over 1. If the bit index is 0, we shift over 0, and it's the 0th place. This is the most kind of... this kind of worries me. So I'm pretty sure that C99 bit flip. So C99 bit flip should be that tilde. That tilde should kind of flip those bits. How to... program to flip all bits of a binary number, right? So C program to flip all bits of a binary number. It should just be the tilde operator. Bitwise complement tilde. Yeah, it's tilde. Flip number equals tilde and then the number. Okay. Satisfied. So I'm satisfied that this flip is correct. So we take this value and we shift it over into place, and we... hold on. Yeah, we shift it over, and then there's just a 1 in one specific spot, and when we flip it, when we flip the bits, then there's a 0 in that specific slot, right? And then we use that as a bit eraser. So this 1 pixel, we use this 1 pixel from earlier. We use the bit eraser on it with the mask, right? So the mask. So the 1 pixel and this 0 bit in this one specific place erases that 1 bit. Then the new bit... the new bit needs to be shifted into place. So let's look at this, right? We do a OR with the new bit, but the new bit is not shifted into place at all. the new bit has to be shifted into place. The new bit is either going to be a 1 or a 0, but that new bit needs to be shifted into place. So, okay, so we solved one of the problems. So, this needs to be shifted over by the bit dex as well, bit dex. Right, so this is the thing we need to overwrite. Okay, and does this still make sense? 0 and then smash together with this and smash together with this, right? So this has a hole in it. This is our original pixel with a bit eraser hole in it. And then we're going to smash it together with this one new bit in the hole position, right? So we're going to get like a little hole in one, right? We're going to create the hole, and then we're going to play putt-putt and get that new bit into that hole, right? And okay, so I'm good up to here. Let's rethink our logic if that's wrong. But I think that's probably the mistake I made. I think that's probably the only mistake I made. I think they were probably good. So thinking it through can just kind of help. Are we back on full bit color? Do we have to change that back? Use 1-bit color is off, so we're not going to actually see anything, right? This is, we're seeing something, but we have to change we have to use 1-bit color again. And right, we're looking at the most significant bit. So we're going to set it in the most significant bit, so we should see something that's like red, right? We should see like red and black is what we're going to expect to see. So we have those stripes on the 4, but if this works as expected, that striped 4 should just look red to us. If we got this correct. Okay, so let's go look at this. Okay, nice. So there's our 4, there's our 5, there's our 6, and there's 7. And then I can't really tell what all these other letters are, but to me that looks correct, right? So we got this big red-black kind of thing. Now, if we wanted to look at the other channels, right, if we want some sanity checks here, we could look at, say, 24 minus 1, so 23. Instead of red, we would have green. So let's give that a run. Let's see if we can now see that in green. Right, so it's the most significant green bit being set, which will give us 128 green. So the middle lumosity green is what we should be seeing. Okay, excellent. Okay, so let's do, so we did 32, 24, and then 16. So 16 minus 1 is 15. So now we're going to have the middle lumosity blue. They're not even going to look at the alpha channel because we're just going to see black if we do the alpha channel. I mean, we could do it just to see that it matches our expectations. I guess that would probably be a good thing to do. And then we'll set it back to 31 after we're done looking at it. So there's our middle lumosity blue, so 128 blue. And if we set this bit index to 0, we'll just see black. So give that a run. And see what we got. Waiting. Okay, so I'm expecting just to see, just see black. Now the data is actually there, right? So it's just that we can't see any feedback, but because we looked at those other sections and we saw all the colors that we thought we were going to see, I am certain that with that black canvas, that's what we expect to see. We're not getting any feedback, but the code is working properly, right? So, but for our sanity, since we can arbitrarily choose any one of those bits, we might as well just choose the red channel, because then when we're looking at the Gpuview, we can actually see what we're looking at, right? So that's cool, because we successfully kind of did this texture dumping stuff, and I honestly thought we were going to make more screw-ups than this, right? We only made one big screw-up, which was that bit packing logic, and we kind of already knew that the bit packing logic was the thing that we always happen to get something wrong with. So nice. So if we do P for pattern, right, we have this editor thingy-mabobber thingy, and the next part is What's the next part? What's the next thing we need to do? So if we look at this, the next thing is we want to get this, we want to create UI fragment shaders. And we want to say, hey, if you're inside the user interface rectangle, when you're in the PAINT5D shader, then render the user interface. So, get status, you can also push this up to kanji coder now that it works. That it's in a stable state, right? So we can clear get status, get commit -am, done, Taudump, Taudump Uirects. Was there anything else? It's like I'm losing track of all the different pieces. Gpuview edits. Let's not mention that it's Gpuview edit. To do UI frags. Do you want to put the to do first? I don't know. Let's just it's kind of like a very cryptic message, but it is very information dense, right? So, right, it's very terse and information dense, or that actually might be just synonymous. Terse is information dense. Terse is information dense, so I don't know why I say terse and information dense. They're synonymous. But right, we did Taudump, we did Uirects. Gpuview we also finished. It was already written, but we made modifications to it so that we could confirm that... oh, actually, I want to start putting the video ID in these things. Oh, well. So the user interface fragments, shader kind of stuff is what we want to work on next. Git push GitHub master. So we'll push this to GitHub, and then we'll also push this up to kanji coder as well. Also, and then we'll take a maybe we'll take a break to watch some Don Ho, because they get up at like 5 or 5:30 or something and start streaming ridiculously early. Okay, and then git push kanji coder master. Let's go look on the Discord. So we could look at the Discord to see, because they usually mention that they're starting to stream on Discord. So, and it's going to take a lot of bandwidth to check Twitch, because, you know, streaming and all that. Let's look at this. Let's see what they're saying. Peanut butter jelly time. I think announcements. Going live 0302. Is it 0302? No, it's not. March 2nd. Well, maybe they don't do every day. Do they not do every day? It's Monday. What's their schedule? 24, 25, 26, 23, 22, 21. I guess let's check Twitch really quick, because maybe they're streaming on Twitch already, and also we're gonna have to pause whatever stream kind of shows up. We're gonna have to pause that. Here I am, just minding my own business. Pause, and then I get distracted. You know what, let's, so we came to a good stopping point for this, right? We're at 7 hours. I want to take a quick break to, kind of like, bother other people on Twitch. So I'm gonna go see what, Rockstar74 is up to. And then I'll probably get back to it, I guess. So yeah, I think that's a kind of a good thing. I think we came to kind of a good stopping point. Let's get back to this at a later time, right? Stop streaming.